Let's go ahead and save that. Okay, so now I'm recording both using NVIDIA as well as WebEx's settings for a double redundancy. Are we still able to communicate? Wonderful. Okay, so I will try to do that. If you notice any lag, slowdown, or anything else besides the typical half a second to a second, please let me know, and I'll turn one of them off. But I've got all of my settings down low to 1080p. We're not pushing 4K this time, so I'm hoping that everything will work just fine. And when we start, I'm also going to give you a little bit of input onto what my setup is, so you know what I have in front of me during class, so that I can work with you better as classes go by. But anyway, I'm going to stop recording at this moment, and we'll start back up in another minute or two. Let's see. Everyone's looks like they're here, but I'm just going to give one more minute in case there's any stragglers. That is one other thing too. It looks like everyone, well, the great news is that you've all done this before in your other classes, so I don't need to teach any etiquette. Everyone's muted, so thank you very much. We'll try to continue with that. I'm a very back and forth kind of person when I teach, so if you have questions, don't feel like you need to raise a hand or anything, please just ask it when necessary. And if that gets out of control, we'll figure something out. But, ask a question when you have it. Don't wait till the end of class because you probably forgot it and I have no idea what the context is. That being said, I guess we can go ahead and begin. So, hello, everyone. If you are here, then you have hopefully decided to register for VR systems, whether that's the introduction course for undergraduate students or the graduate level just VR systems course. I am going to have a few questions for you. This is the first time the course has been offered fully remote. I'm not going to say online because Rowan has a very different stipulation for what an online course actually is. But that being said, I don't anticipate the learning experience for you to be much different than what you would get out of a normal classroom. So I don't want you to feel like you're getting less of a course. If anything, I'm putting more into this course than I ever have any course I've ever taught in the last, I've been teaching since around 2009. So a lot of effort's going into this, and I hope it gives you all the information you need and teaches you what you need to know for the class. A couple other things I just wanted to mention too is I am very used to reading my audience. I'm used to having some faces to look at. And at the moment, I have a bunch of initials. I have no faces. So I'm going to really heavily be relying on you to give me feedback, to let me know that you are engaged, that things are making sense, that you're interested in what's going on. I can't make you like anything. I need you to show me you enjoy it. So please be engaged, be active, and I'm here to help you in any way possible. That being said, what I've got set up, what I have set up here is I've got kind of my not nearly soundproof enough cage, as you can see behind me, to reduce ambient sound and noise. I've got a webcam. I have 2 4K monitors behind me. I will be running everything at 1080p though for streaming. That way, no one's systems are completely destroyed or the bandwidth isn't taken up. I also have a Wacom touch panel with the screen duplicated so that if we need to do any dry erase board type stuff, I can do that in front of you as well. So we have pretty much everything we need right here with us, so long as we all have a stable internet connection. That being said, I plan on recording all lectures and posting them online within 12-ish hours in case I need to do any processing or anything else. Let me know at the end of this if WebEx works for you. I know Zoom is another option, but there are other ones available. So if none of this is what you want or doesn't meet your needs, let me know and we'll see what we can do in the future. That being said, let's just jump right into it. So at this point, I'm going to go ahead and screen share. And like I said, I got a dual screen monitor set up here system. So I'm going to have my PowerPoint on one side. I'm going to keep the WebEx open on the other one so I can still see you all and have the chat open. By the way, if you're not familiar with WebEx, you probably are at this point, but there are chat and participation GUI options that are a lot of time get hidden or removed. So make sure you activate them so you can see what everyone else is doing in the classroom. That being said, we're going to go ahead and share my screen, and I'm going to cross my fingers that this doesn't cause everything to completely fall apart. So let's go ahead and share the screen here. All right, so it's giving me this nice little bubble. I'm going to move that out of the way for now, and we can start at the very beginning. So yeah, general course information, virtual reality systems, fall 2020. This is probably the 5th or 6th time I have taught this class. And what makes this one different is that I have completely, from the very ground up, redone the entire course. So you are getting a truly unique experience. No one else has gotten this before, and I hope you find it valuable. My name is George Lecakes. People, for some reason, try to pronounce it a variety of ways, but it's really simple. It's just Lee and then Cakes. That's it. Topics covered. I wanted to go over this. I know we're past the usual drop ad period. I'm sorry about that. I don't like how the Monday ends up getting delayed 2 weeks, but that's just the way things are. So going over these topics are broken down into 2 different colors, or 3 really, but the idea is that we have the first half of the semester, and that's where we're going to be covering the theory. Now, don't take that to mean that we aren't going to be doing things, because that is everything in this class. You will be coding, you will be creating. But the first half of the course is really about solidifying your understanding of all these different systems and understanding how they work and how to make things work the way you want them to, getting a real idea of how these systems work on a low level, as well as the high level of the Unity engine that you'll be working with. So obviously week 0, if you haven't done that already, please do that by tomorrow. That's when it's due. But you should have or will be installing and your applications and making sure that they all function on your computer. Week 1, which is this week, is our overview, which we're doing now. We're going to go into some general things about Unity. If you've already looked at the site, you'll notice that in week 1, I have some pre-recorded videos. Those videos are Unity fundamental videos in case you want to get a general knowledge. What I hope to do is split some of the material across offline pre-made, where the coding, the things that students always ask me to do a second time or just can't follow along in class with, that's the kind of stuff I'm going to hopefully have on the videos, so you can play, pause, stop, record. You can do it whenever you want to. You always have a reference to work with. The lecture periods right now are, of course, obviously asking questions. You have the chance to do that. But it's also a time for me to go more into the theory of how things work. And that's what I'm going to be spending a lot of time on, is going over the PowerPoint lectures that I put together. Now, the lectures are also all available week to week with this. So if you miss something, it's always there as well. But anyway, week 1, general knowledge and so forth. Week 2, we're going to be talking about inputting data. That is, what is data for us? Well, data are vertices. That is the core data type that we'll be working with, as well as creating 3D models through inside of Unity without using a 3D modeling program, doing it via code. Then we are going to work with, in week 3, we're going to jump into shaders and rasterization, which basically means taking these discrete points of data, these individual points in 3 dimensions, and understanding how a computer converts them over into a rasterized or a 2D pixel value using a GPU or whatever you happen to have doing that processing. Week 4 is where we dive right into simulation of light. This is a huge topic, and we can't cover everything in this class, but we will cover the fundamentals of the most popular methods used over the years, as well as the latest methods like physically based rendering, which are very popular today in terms of simulating light. But you'll find that literally everything about making a scene look realistic is about simulating light accurately. If you can do that, you can make a room that is completely devoid of color or really much of anything look realistic if light is properly simulated. Week 5, we're going to go into textures. Now, textures are used for visuals mainly. It's a cheap way of encoding color information onto a surface, but it's also used for a ton of other things. And we're going to talk about all the different methods that you're going to use textures for in order to store data and information inside of an image, which is an interesting thing to think about. Instead of having a database, you actually use the image, because images are readily and easy to use on a GPU. So we always use the kind of data that's easiest to work with. And in this case, on a GPU, storing things in textures is kind of the way to do it. Next up in week 6, we cover animation. We're going to cover not the animation fundamentals that you would take in an art class. We'll talk lightly about them a little bit, maybe some anticipation here and some of the background of where it comes from. But we're far more interested as engineers and some computer science majors who take this course in the theory behind it, how these animation systems work, how you can make vertices move, whether those are individual vertices through things called like blend shapes, or if they're entirely complicated rigs of characters using complex bone systems with inverse kinematics, or on the fly, developing and using things like Bezier curves or other representations to sample animation curves over time. Those are the kinds of topics this course is going to gear you for. Then we hit the red week 7, the online midterm section of things. Now, I just noticed that I don't have the chat window open, so I'm trying to figure out if I can turn that on. There we go, good. So then we hit the online midterm, and this is the perfect time. You've got the basics down at this point. You've got the theory, and you'll be taking an online midterm. We will not have a standard lecture that week. You'll have the entire week to figure it out. In the past, my midterms have always been handwritten essay question style things, and obviously that's not going to work in this case. So instead, what we're probably going to do is going to be some sort of mix of multiple choice, some essay, and some other things. Typically, my midterms are not code-based. Those are the homework assignments. That's the final project. Midterm is usually focused on theory. So maybe I'll break that this year just because we're more online. And since you'll have the entire week possibly to do it, I'm still kind of figuring out how I want to do this properly. Maybe we'll work in some coding examples at that point, but I'm usually against that. The first week is about theory. Then everything after that is showing you understand it and can implement it. Starting in week 8, we're going to go into extending the Unity engine. Now, this is incredibly important. The Unity engine has a huge, rich feature set, but it doesn't do everything for you. And what we'll discuss is you'll be creating your own final project. You can work in teams if you want to, or not in teams. It's entirely up to you. But you'll probably want to add features and functionality to make your life easier. And we'll talk about the basics of extending the Unity engine to do things that you want it to do easier. Week 9, we're going to go over the entire creation process. That is the pipeline and best practices to create content. We're going to get kind of both low level and high level about how data needs to move between different applications and how to kind of protect yourself and manage projects, especially when they get very large. Week 10, excuse me, I'm going to get some water. I'm losing my voice here already. So week 10, we're going to talk about Unity input, both input from like keyboards and whatnot, and just general input into your program. We're also going to talk a lot about management and control. I find this to be a topic many people just skirt over. They'll show you, oh, here's how to do input, or here's how to load in a model, or here's how to do basic stuff, but they don't tell you how to manage all those systems together. And usually that's incredibly important. Otherwise, you end up with hundreds of scripts, all with weird names and no way of understanding how they work together, their hierarchy, so to speak, or a UML diagram or something comparable to that. Week 11, 3D modeling and unwrapping principles. This is where we're going to jump into Blender if that's your 3D modeling application of choice. It's the one we will default to in this course. However, if you want to use a different program such as Maya or 3D Studio Max, I'm fine with that. I know both of them very well. If you go with a completely different program though, like Houdini or XSI or some of the other ones, please don't do Sketch, whatever that one is, the Sketch one. Those are just going to cause a lot of problems. But if you want to use one of those, I'm not going to stop you. Just realize my ability to help you is going to be, reduced. After we do that, we're going to then hopefully go into Substance Designer and Substance Painter in the following 2 weeks. And now these are amazing programs. If you haven't used them already, they are industry-changing applications that I'd say really started becoming a heavy hitter about 3 or 4 years ago, with Blizzard and a few other companies beginning to adopt it into their pipeline. But with that, we'll also talk about the theory behind creating procedural textures. If you haven't seen it before, there's a lot of individuals who are obsessed with the idea of making a game or something visual as small as possible. Recreating the entirety of Doom to be under maybe 50 kilobytes or something. And many of those techniques come from being able to generate things from mathematical or algorithmic expressions. And that's where you get procedural stuff from. The cool thing about Substance Designer is it has all that built in into a GUI interface, which allows you to connect things with different operators and kind of get the output. But we'll also learn how to do a little bit of that via code as well. Then Substance Painter, and as I mentioned in the videos and in some of my emails, that's the one program that's probably going to cripple a lot of your systems if you're using a very low-end system. Try to use it, try to work with it because it will drastically improve and speed up your workflow, but it's not a requirement. And if I find out that, 3/4 of the course can't launch the application, I will show you other methods of texturing your object, whether that is old school Photoshop-esque stuff with 2D stuff, or there are some other applications that are starting to come out there, but they're not quite as good. But hopefully we'll be able to use Substance Painter. Finally, week 14 is AI and navigation. So we're going to talk about how Unity has several nav mesh systems that allow you to enhance or do proper movement controls. However, in reality, that's just the basics. You still have to apply logic, how you're going to move, what choices you make, and that's where we get into the AI portion of this. Please don't confuse this with topics on machine learning. We will not be delving into those ones. Those are entire courses in and of themselves. These are very simple AI techniques that we can employ in a single class period to make some interesting stuff happen. And then finally, it says week 15, but since we lost a week, I might need to condense one of these weeks down. But the idea is our final week is going to be the final project, which I'll talk about shortly, and an optional final exam, which I will also discuss more about shortly. Let's continue on. So now that I've talked about the course and hopefully everyone is still here, or you've decided to, do that handwritten form to transfer to a different course and you've left, let's talk about myself. My name is George Lecakes. I'm the director of the Rowan VR Center. You can reach me at lecakes@rowan.edu. You may call me George. That's fine. I don't have my PhD yet. Or you can call me Professor Lecakes if you want to be a little more formal. I am a Rowan grad all the way. As you can see, I have a BS in Civil and Environmental Engineering, Master's in Electrical Engineering from Rowan as well, and I'm hopefully going to complete my PhD this fall of 2020. And I was hoping that I was going to have my certification by now, but they're taking so long to grade the exam. I took a Unity certification for expert level programmer, and it's a beta, and I'm one of the people actually determining what the answers are. So they're taking their sweet time getting the results. So hopefully I'm also certified as an expert Unity programmer. We'll see about that. And these photos on the side are me in probably 2005, 2004. Down at NASA Rocket Engine Test Stand. This gentleman over here is Dr. Srikanth Mundam. If you haven't met him yet, I recommend you do. And of course, this is the much loved Dr. Schmazel, us all down there at a large, this is where they test space shuttles, basically. So good thing it wasn't on at that point, but they literally divert an entire river into this thing to fire it. And I call these cloud makers because literally just bellowing out cloud steam, just tons and tons of steam making clouds going off in a distance. But that's where my story with VR and computer graphics actually begins. So if you notice, my undergrad was in Civil and Environmental Engineering, nothing to do with it whatsoever. But by working on this project as part of my clinic project in 2003, I got into the world of VR, into 3D modeling, and that's how I am where I am today. So it just goes to show you that things, well, can take you strange places. All right, before we get into some more interesting stuff, I am doing my background research for my dissertation, and I've got some quotes that I thought might interest you over the last 20-some years, actually starting in the early 1990s, about VR. And this might help to set up kind of the image of what VR was, especially when I was, much younger, 10 years old all the way up till your age at this point. But here we have Discover in 1992. Although the computer graphics appear rather simple at this stage, it shows that virtual reality is not limited to large, high-tech research institutions. And the interesting thing is that really hasn't still changed today. Even though we have commercial versions, they're not in everyone's household. And many times we look at the big R&D facilities that are producing really incredible high-tech R&D. Even Magic Leap, just 2 or 3 years ago, was still hidden and not shown to people getting their billion-dollar investment. So even now in 2020, it's not too far from the truth. Here, Scientific American, virtual reality has the same potential today as PCs did in the late 1970s. Well, that was 1993. In the late 1970s, if you think about it, that's when PCs in people's homes started to really boom. It's been almost 20 years, and we've only just barely scratched the surface of VR as something in everyone's household. So, still didn't quite hit that mark. Another one from Popular Science: the reality of virtual reality is that it takes a lot of computing power to create. Well, the good news about that is, well, for a while at least, Moore's law continued to go somewhat okay, and teetering out recently. But we have other things. We have the GPU that was developed in 2000, which provides much of the computation power we need. And even laptops at this point are able to run VR-ready games. So we've got the computing power down at this point. It's a lot of other things that we need to work on. 1993 again, it may take a few years before such computer simulations become commonplace in the classroom. The way off, few years. I don't know about you, but I don't have VR in any of my classrooms, even though this is a VR course. It's still something that's toyed around with, played around with, but not really anything you get. You might have the tech guy at your high school who has a VR system that you get to play around with on a weekend, but it's kind of it. So that didn't pan out too well. Aperture. Well, it is a major pain in the neck to wear a head-mounted display. And we still have people complaining about that today. If you look at any of them, even if it's the smaller Oculus Go, which I have right here, it's still a little heavy and it's still a little clunky, and you still get sweaty around the face. So we're still not there yet. Another one from Popular Science. Right now, the cost to benefit ratio just isn't there. And if anyone has gone on Steam recently and saw how much the Valve Index is, yeah, it still kind of isn't there, right? You want to play Half-Life Alyx, but you got to throw down $1,000 to do it, plus $50 for the game, unless it was, I think at the time it was free still. But yeah, that's still pretty pricey for most people. Even the Go can cost $200. So, it's still not, it's better. It's much better. It's not $100,000 or millions of dollars, but it's still hard to get that into every person's house. 1994, Scientific American, imaginary environments are still far from real. Do understand when that was said, though. 1994. CG was just kind of getting into movies, and even then it wasn't very good. And most of the CG you think is CG wasn't CG, like in Jurassic Park, where it really was puppets and animatronics. But 1994, we didn't have a GPU yet. That is called a GPU. We had cards, video cards that were created, but they weren't the GPUs you're familiar with these days. 1995, bulky head-mounted stereoscopic displays will be replaced by lightweight glasses that can superimpose synthesized images on the real world. Well, hey, that sounds a lot like augmented reality, doesn't it? And, that's kind of the direction we're going into. Things like HoloLens and Magic Leap and many others, those blur the lines of what VR and AR actually are into the terms of mixed reality, where you're kind of doing both at the same time. Then we have VR has always been a very personal experience, and one that requires cumbersome headgear most folks would not want to wear in public. 3 years later, and we're still complaining about the weight of headsets. Popular Science, for all that potential, what we've actually seen VR do is enable us to do old things more efficiently. This is actually a knock at VR from the article. This was saying that VR, it promises all these amazing things, but really all it's done so far is just things we already could do are a little bit easier instead of doing really amazing stuff. Then don't confuse it with virtual reality, that now ancient technology for implanting yourself in a computer-generated world. Well, it's 1997. We haven't even delivered on the promise of VR yet into people's homes, but we're already saying it's old, ancient, and it's archaic. We don't need it anymore. So make up your mind. Obviously, these are Popular Science articles. They're sensational. They're meant to draw your attention. But you can, hopefully you can plot sort of the ups and downs that this technology has gone through. Next one, and you need to be able to create accurate representations that you can also render at least 15 times a second. If you know anything about computer games, try playing one at 15 frames a second or with some serious lag. Yeah, most people would say you need at least 30, need at least 60 if you want to rotate your head, and most VR systems are going for 90, if not 120 or above. So that notion of only 15 times a second, and that came from a researcher in the field of VR at that time. That just shows you how wrong people were back then, or how much they were trying to what's the right word, keep VR alive by lying a little bit about what the requirements are. 1999, the last one I'll mention. Virtual reality pioneers donned heavy headsets to view crude, jerky video displays. 1999, we're about to hit Y2K, right? Every civilization's going to collapse, and we still can't get over these jerky, heavy headsets. Now I'm going to stop with quotes because once 2000 hits, that's the game changer. That's where the GPU is coined by NVIDIA and gets into people's computers, consumers, and that's where VR really begins to have a chance. But I just want to take some time to show you some quotes from other people in the industry. Now, what I wanted to do was talk to you. I could list, I mean, really, just go on any game website right now, and you could look at different VR examples. But I want to give you examples specifically that I've been involved in. So you know, one, that hopefully I know what I'm doing and I'm teaching you for a reason. I'm teaching this course for a reason. But two, this is VR at Rowan. These are all Rowan produced things. So you get a sense of what knowledge information I have and what knowledge information the students here have and what we've been training and teaching people and what you'll probably can expect us to be able to help you with. So over here in the top left is a visualization of Philadelphia. This demonstration was actually created in 2 weeks' time, and it was for NBC to showcase visualizations of the Pope coming to Philadelphia for a news piece they were doing. To the right of that is the Health and Science Campus. This is a 3D rendering of a future campus that never quite happened in Camden. And then on the bottom left, we have a visualization of a light-baked operating room. And the idea is that in this cave system, which is a walk-in VR device, you go inside and you're able to actually see or feel, not feel, but walk around as if you were really there. And the camera tracks your head and you can move around with different objects and place things where you want to and test an operating room before it happens. And then to the right of that, Rowan has successfully used VR several times to help get donations, not just donations, but also to show off visualizations of future up and coming things. And then you change the name of who the like the atrium is. So it's like, you know, the George Lecakes atrium for things that can do better. And what we do is we bring in the donor, you know, George Lecakes in that case, like, check it out, your name could be here if you give us $500,000. So that thing, that actually really works because the person gets to see an architectural visualization of what it will be in the future. They get to see exactly what they're throwing their money at, pretty much. Then we have simulation. My work with NASA as a master's student is on the far left up top, and that's a methane thruster testbed platform rocket engine system that was developed in VR to show simulation results. Next to that, we have a civil engineering application where we did truck driver fatigue inside of a VR system so that you drive around and you see, you drive around for 2 hours and you see whether or not you get fatigued, and it tests you in different ways. Then the far right is another civil engineering application with rainfall simulation analysis. We actually wrote our own simulation system for how rain falls down, where it goes, and then you can visualize all of that in VR. In the bottom left are two of our former graduate students. This is a visualization of a hurricane off the coast of the United States. The idea is we're talking about resiliency in New Jersey, and Rowan wanted to go after some resiliency money. So by creating a big, you know, VR showpiece, you can invite commissioners, you can invite politicians by, and they had this really awesome thing to look at and be photographed in front of. And it shows, you know, big tech here in South Jersey, because we know we're in South Jersey, right? I mean, it's not exactly known for as a technology upstart, but having this stuff here can, you know, influence a lot of people. And then finally, on the far right down here, we have something I did for a company called AlanCon, which is a visualization of their generators and these, you know, windmills off of a coast. Then we have the DoD work we've done. If you've heard of NAVSEA, or some of you might get jobs there, we do a lot of visualization work. You can see in the upper left-hand corner, whether it's training or just visualization of different locations. Then on the upper right, we have cold spray. You might have heard of a few projects that came in recently to the tune of like $7 million or something. Not our work, unfortunately, but we started some of the cold spray work with them, which was creating training scenarios where they could actually use this technology, because it's at the time it was very rare and there were only a few of them in the world. So why not train with VR before you actually do it? Then in the lower left-hand corner is a visualization of an aircraft carrier with the Joint Unmanned Combat Aerial System called the JUCAS, which is a autonomous, you know, flying vehicle that will take off and land. And yeah, if you're interested, I'm not going to play them because we've got plenty to go over, but there are a few links here and there. You can click them to watch a video that has a lot more information. The Picatinny Arsenal one there is something at least one other student in the class worked on, which is about a Jeep and being able to train a person for situational awareness. So there's another example if you want to check it out. Then we have medical, and this is a big thing, or at least it should be a big thing because we have 2 medical schools at Rowan, right? So on the far left, and unfortunately because of COVID, I don't know if we'll have a tour, but normally I would take everyone on a tour of our large-scale 10-sided cave system, which you see half of over there with someone standing in front of a medical visualizer, which basically it takes in CT, MRI, PET scan, it doesn't matter what it is, it's 3D voxel data and visualizes it using something comparable to a ray tracing algorithm that I developed. Up at the top, we also have some augmented reality projects we worked on. Here is a ubiquitous navigation thing where a surgeon can put on, it was in the early days of Google Glass when everything could be done, but in reality, nothing could be. But the idea was to have a Google Glass system hooked up to show off vitals and other information to the doctor as they're operating on the patient. Below that is another voxel visualization of the inside of a mummified falcon. So the medical visualizer that I wrote can take in any kind of data. It doesn't have to be medical. In this case, they are scans of a falcon mummified in a tomb, some BC time at some point. But they scan the thing, and with this, we're able to rip apart all the different layers and visualize them inside of it without destroying the artifact. And then below that is visualization of EEG EEG points on the brain. And then there is a video down here if you want to watch a longer segment to see some stuff. But then there's education. This one's actually pretty popular lately. Up here in the upper left is a training simulator I made, which allows people to learn the basics of nursing. They have to go through a checklist of different things to check on the patient. Then we have education. Here is my son with a 3D printed dinosaur jaw with sensors on it that are picked up. And as he moves it around, a bone in the VR environment moves around with it, and you have to put the bones in the right spot. Here, he's trying to stick the jaw back in the jawbone where it belongs. To the side of that one on the far right is a Caterpillar demo I made a long time ago for kindergarten, first grade, and second graders who came into the system and got to shrink down to the size of a caterpillar and see it and interact with it. And then a much more recent and ongoing project right now, once again, a few students are working on this who are currently in the course, is a Warsaw visualization of the 1940s during the occupation by the Nazis. And the idea is to take us back in time to a period that no longer exists, not only because, time marches on, but also because it was bombed and over 80% of the city was destroyed. So there is nothing there. We are literally recreating this in VR so we can experience it. And then finally on the bottom far right is a gentleman some of you may know, depends I guess what you watch, but this was a show called Sci-Fi Science with Michio Kaku. He came and visited myself, I'm actually right there here standing up in the red shirt, to see our cave system for a episode of the holodeck. So we got to show off our system and educate a lot of people about where VR is right now. Now, this one is a little risque, but this is VR in the arts. So we did some technical stuff. We did some interesting educational stuff. Now we're going to do some stuff that maybe some of you might not be interested in, but it has its applications. So this is VR used by a dancing instructor here at Rowan University. And the idea was to provide a virtual backdrop for the dancers on the live stage to dance with. And this rather risque picture up here is actually a dream within a dream almost, where the guy is actually on stage, he lays down on the floor and has a dream sequence. And then she's kind of up there standing or sitting and reacting to the dream. She's actually watching his dream behind her. And then up here, he's having this sort of, I don't know how to describe it, but you can probably figure out this dream sequence, what's going on. But anyway, that was a very weird and wild project that we worked on. And it just goes to show you the technology can be put anywhere so long as someone's interested in integration. Below that, we have an aquarium that someone developed, or actually I developed a good bit of it, but was used by a dance team as an interactive backdrop. And then next to that was another one that was developed where a dancer puts sensors on their arms and legs, and they have a dance troupe in the background, these little tiki guys, and they would move and mimic whatever the dancer would do as well. So once again, just goes to show you can do some interesting things. And then every now and then I get to have some fun and actually make a game. So here is a Halloween adventure we made called The Rite about 2 years ago, which was in the 10-sided cave. A group of 3 people got to play together. 2 people have flashlights and they only have like 10 or 15 seconds of battery life, so you have to alternate and conserve. Another person has the controls but no light, so you all have to coordinate together. Next to that is an escape game we made for a an escape Halloween haunted house. And then this dinosaur one I talked about before as well. So anyway, all I wanted to do was to show you some different examples of where VR can be used. I know there are examples that you never find in a textbook because I haven't written one on any of these yet. So they're all new, interesting stuff for the last, I'd say 15 years that I've worked on in different capacities. Now let's talk more about the course. So the format. Live streamed lectures every class period, similar to what we're doing right now. Theory will be via PowerPoint. You'll have access to all those materials. Usually they will become unlocked the day that we'll have the lecture in the morning, or maybe during the weekend. I'm not sure yet. It depends on what's more useful to all of you. Live demonstrations, questions and answers. Then we have the Canvas, where it's going to contain all the lecture material, assignments, quizzes, midterms, and the final project information. One thing to note is that every week we'll have a brief multiple choice quiz. They're meant to be short, they're meant to be quick, and they're meant to show you whether or not you've mastered the material or if you're slacking off. Once again, I don't have you in front of me every week. I can't drill you or quiz you like I normally would. So this is my way of trying to make sure you understand where you are in the class. It's a favor. I'm not trying to just get needless grades here. I'm trying to make sure you can see where you are and whether or not you need to spend a little bit more time on something to truly grasp what it is, because those multiple choice questions will feed into questions on the midterm. So do make sure you understand them. For right now, I'm going to have all assignments submitted through Canvas, unless we hit a data cap. I just found out that Canvas has a 500 megabyte data cap. At least that's what it's telling me. And our Unity projects, especially the final project, get quite massive, at least a few gigs. So we're probably going to do some sort of a Drive, Dropbox thing when we hit that wall. So we'll get to it at some point. Then, of course, the Slack page, I've already sent that out to everyone via email as well as an announcement, and I think the link is still in the Canvas page. But there's the link as well. Make sure you join that if you want to. It's a great place to talk. I know probably every class at this point has a Slack page, but it's an easy way to answer questions. Offline tutorial lessons hosted on a playlist. So I will be putting all of the offline lessons that I create into this playlist right here on my own personal page. I've started to put in up the week 2 content. I'll put a few more of those up later this week as well. If you want to jump ahead, you can, but you don't have to. But really, I'm trying to distill as much of the programming stuff, the kind of boring stuff during class that you might not want to watch. You might want to have a video so you can go back to later and re-record or re-watch. So that's where that stuff is. Let's go back to, here we are. Well, so let's go to Canvas right now and take a look at the page, and just so we're all, understand the rules and policies and regulations and all the stuff that I'm required to go over. Let's see, we have virtual reality systems, and yes, so of course the syllabus, we have to go over that because that's today. Make sure all that's correct. Make sure you're in the right section. If you aren't, by the way, I believe everyone is, but just for those people in the undergraduate section, make sure you are supposed to be in that section. We do from time to time have graduate students who choose the wrong section, and that's a real pain by the end of the class to deal with. Contact information. I do not recommend you contact me by my office phone, just because I only have one line. I have multiple locations I'm at right now, 2 different locations at Rowan, and I only have one phone at one of them. So there's a good chance you won't get through. Email, Slack, etc., or asking for a WebEx one-on-one if necessary is the best thing to do. If you want to, you can go through the objectives of the course. All this is going to be met, the different programs that you need. 2 programming languages you will become familiar with. One is C# for Unity. It is C#, it's just Unity has a lot of namespaces and methods and classes and structures, in addition to the standards of C# that you'll become familiar with. And then there is the C-style HLSL. Now, at the time, I called it CG, but really it's all high-level shader language. This is the language you'll be learning to program your graphics processing unit on. It's very C-like, has no OOP whatsoever. So if you've been doing any embedded design or hardware design or whatnot, it's not going to be that low level, okay? Because you don't do that kind of stuff on a GPU. But that's the style that you hopefully have become familiar with through electrical engineering courses. Now, let's see. Texts. There is no textbook for this course. Like I said, this is based on close to 20 years of experience. But you do have access to all the lecture material, and my lectures are usually very complete with a lot of unnecessary information that you might not even want to read. So you'll have everything you need. Software, hopefully you've all followed along with this. The Unity Hub in the 2019, we'll talk about that shortly. Visual Studio 2019, a Blender version 2.82 Plus, and of course Substance Painter and Designer if you can. And once again, the big thing that apparently really ruffled some feathers is my desire to ask you to have a GPU if possible. The idea is just that we are dealing with a topic of VR, and you do need some power behind you to really get the most out of it. So if you have access to a dedicated GPU, great. If you don't worry. You can still do it. It'll be emulated, it'll be integrated, but it's okay. We'll get through it together. Policies. Typically, I ask you to submit things with your last name and then your first initial and then the assignment number. That's so that I can coordinate and search for things very easily. Please never submit something just as my assignment, because who is my? I have no idea once you've given it to me. You can submit as a zip, a RAR, or a gzip. I don't care which one, but do zip everything up for everyone's convenience. Don't send me a link to Google Drive that has not been zipped, because Google Drive takes many, many, many minutes to go through all of your files and convert them over to a zip file, which I end up just sitting there for 30 minutes waiting for that to happen in some cases. So please zip it up first. Late work is not accepted unless it falls under some reason. All the due dates are in Canvas, so you should know everything. I'm also relatively lenient, so if you do have a reason or something happens, I have no problem pushing due dates. And if you have some sort of a reason, like a documented reason that you need additional time or anything like that, that you've registered with the university, if you have not already done so or I have not communicated to you about it, make sure you contact me and let me know, because there's actually a limit to that if you don't discuss it with me of several weeks. I forget when it is, where I technically don't have to adhere to that anymore. So if you do have anything like that and I have not already spoken to you about it, please do so as early as possible. I'm usually pretty good with grading assignments, especially since some of them are automated-ish with Canvas. So you should hopefully get most assignments back within 2 weeks. And I will try to do as much through Canvas as possible. The only thing I want to mention is the grading system down here. Canvas, in the way it's set up to auto kind of tally your grade, is not correct. It assumes you have every single assignment known and the exact point distribution known before the class starts, which is never how any class ever works, because there's extra credit and other assignments and all kinds of things that happen. But all you need to know is that this is how things are going to be broken down. So however many quizzes, I spelled that wrong, however many quizzes you have, that is going to be 20% of your grade. So you can always figure that out by adding them all up, right? And then determining how much of a 20% that would be. Same thing with homework assignments, the midterm, and of course the final project. Notice that the quizzes are the least amount of your grade and that you will have a lot of them because you have one for almost every week that we will be in session. Therefore, they're not meant to hurt you. It's meant to be an easy way to get a good bit of points for your class. Things you don't want to mess around with are the midterm. Spend a good solid week studying for it. You're going to have time to do it, but getting it done and quickly and fast is preferred, believe me. My midterm is not meant to mess with you. It is, if you know the answer, the midterm can be done in 30 minutes kind of thing. If you don't know the answer, that's when people are staying for 3 hours. You know, that's when you didn't study and you know you didn't. And then the last thing we are going to talk about in this course is the final project, because this is one of those things that's it's the culmination of the entire class. It's meant to take everything you've learned, all the lessons that we have, and have you create something either by yourself or as a team. And every year, the final project is different. Last year, my final project got hijacked by the provost of the university, and he forced me to use another project, a Warsaw project in my class. In prior years, I left it open to the students. However, this year, I'm going to give you the topic, and you get to work within that framework to create whatever it is that you want to. One thing we do need to do is I need to take attendance, because obviously attendance is due tomorrow. So what I would like to do very quickly is do that if possible. So I'm going to stop sharing my screen for a second, and I'm going to take attendance right now. I think we've given everyone enough time to know whether or not you're here. Attendance is important because if you're on scholarships or anything else, not saying you're here right now could make you lose those scholarships. And yes, I have actually had students lose scholarships in my class because they didn't attend course. And I wasn't doing it on purpose. I had no idea at the time. So what I'm going to do is, let's see, I am not sharing, correct, right now? No one can see my screen? Wonderful. So what I'm going to do is I'm going to log into Banner right now. I want to go through the list. And obviously I've got everyone here right now. If you would like to chime in and say here, that's entirely up to you if you want me to hear your voice. If not, I'll just go through, find your name, and I'll tick you off. So technically you have it easy. You don't have to respond. Let's see, you could just log in and walk away or be watching something else. So let's see. Sorry, this is going to take just a second because Rowan has made things unnecessarily difficult. Let's see. We need to do section attendance verification. And we are going to start with the Intro to VR course. So Ryan Boylan, is that how you pronounce it, Ryan, if you're on?
Yes, I'm here.
Wonderful, thank you. Attended. Then we have Richard Dell. Are you here? Yes, I see a Richard Dell. You don't have to respond. I'm going to assume you're there. Alexandra Jackson, are you present?
I'm here.
Wonderful. And by the way, if I do pronounce your name wrong, feel free to speak up and correct me. Michael Johns.
Here.
Wonderful. Kyle Limbaga.
Yeah, here.
Great. Lynn Zihao. Oh, I see here in chat. Thank you. I need to have a sound for that. Then we have Jacob Matteo. Trying to see.
Here.
Thank you. For some reason, I don't have everyone showing up on the thing. Then we have Robert Mullen.
Here.
Thank you, Robert. Sean Prendergast. Yeah. That's an interesting name.
I'm here.
Thank you. Kaylin Rhodes.
Yeah, I'm here.
Great. And then we have Nicholas Riggins.
Here.
Thank you. Nicholas Shuley.
I'm here too.
Great. Allison Silvestri.
Here.
And Dawson Tokarczyk.
Here.
Is that correct? Did I say that right?
Yeah, close enough, honestly.
All right. Well, it's up to you if you want it 100%. Ben Zawelski.
I'm here. It's pronounced Zalewski.
Zalewski. Okay.
Yeah.
Don't worry, I'll probably just call you Ben. So let's go ahead and we'll confirm everyone. Great. So you're all good. So hopefully you attended all your other courses and you won't lose your scholarships.
Sorry. I suppose I'm left out. I don't know. You did say my name or not. It's Deep Patel.
That was the undergraduate section. We'll be moving on to the graduate section now. Okay. And because we got a few more. So we have Josiah Bell.
Here.
Thank you. Mahmoud Gamisi. I see you right here, Mahmoud. I'm going to assume that you are.
Yes, I'm here.
Wonderful.
I'm here.
And then we have Deep, who just talked. Yep.
Yes.
And then we have Kayla Ritz.
Here.
There she is. And we have Alexander. Alex. Yep, there you are too. Peace.
There you are. Peace. Hello.
Wonderful.
Wonderful.
Has anyone been missed? All right, I'm going to assume we're good. Everyone is properly entered in. No scholarships will be lost. All of your money is safe. So we can, let's see, what time is it right now? 5:48. So let's continue really quick and see if there's anything else we need to go over. Let me share my screen. Now I can actually do that. All right, everyone sees everything? Great. Okay, so once again, just going over the different things. The modules is where you're going to want to go for everything. The order isn't super important. I always put the quiz at the end because hopefully you've gone over all the other information before you try to take the quiz. So please do that. And I will be posting the live lectures up there either directly, or I will post them on YouTube under like an unlisted thing so that you don't have to worry about anyone publicly having access to our conversations. And then I will put those links up inside of here. Let's see. So the only other things I wanted to mention was that hopefully you have already completed week 0. And if you have not, you have until tomorrow at 11:59 p.m. I almost always have homework due not the day of a class, but the following day at some point, usually at the end of the day. That way you can ask me questions tonight, figure out what you did wrong, and you got at least a day to get it right beforehand. Okay? So that being said, before we move on to actual content, does anyone have any questions in the class or anything they want to say? Once again, I don't have the chat open because it always auto closes the chat. So let me make sure that's open. All right. With that, we'll continue. And I don't know if we'll go the full time tonight. Probably not. So don't worry about that. Once again, the in-session classes, the things we're doing now are really about you getting a chance to learn and engage with myself or other individuals about things. So there's this first week, we're going to take it a little bit light. We're going to review object-oriented programming. The reason why we review it is because I noticed that you take a class in Java, right? A comp sci course that's required as an electrical engineer. But the ideas and the reasons why you do OOP never really get through. And the very first class you create, the very first script you create uses object-oriented inheritance. So if you don't understand these concepts or if they're a little hazy, that's why you want to pay attention. And OOP is all over the place. I mean, it's supported in C++. Notice I said supported. It actually is not. C++ is not object-oriented. It's supported in it. But then Python, Ruby, not Lua, but several other ones. It's an important concept to learn, and it will make your coding a lot easier. So let's just dive into this real quick. So OOP, all the slides are already up there if you want to follow along, or we can talk about it here. And once again, please, if you have questions, concerns, comments, interrupt me just like a real classroom and say something. Otherwise, we're just going to keep plowing through. So OOP, what is it? Well, the idea is that we have objects and that they have operations. And at the abstract level, objects, these things, get a request or some sort of a message and they respond to it. So you can think of everything as an object, right? As as an actual little, let's go to a pen. You literally think of everything as a box, and we have inputs and we have outputs. And you write the functions, as you would call it in C, or methods, as we call it in C#. I will use them interchangeably in this course. So function or method, same thing roughly. It doesn't really matter. It's just how people talk with different languages. But you create a box that has the ability to request or send messages and receive them as well. Technically, in a pure object-oriented world, that's the only way you're supposed to execute any kind of an operation. But almost all the time, we never, ever stick to that unless we're using a true object-oriented language. Usually languages like C# and Java hold us to that, whereas other languages that, like I said, support object-oriented programming, like C++, allow us to completely break all those rules in order to get performance out of it. And that's one of the reasons why you'll be able to do a lot of things a lot faster in C++, is because you can break those rules that sometimes slow things down. In theory, OOP isn't meant to slow things down, but it can if you program them wrong. And most of the time. Oh, go ahead.
Yeah, I was wondering if, in addition to that, if you could give an example that we might expect to see implement ourselves.
Sure. What you might see is a emotion system. So what you would do is, we'll see an example later on, but you might have an object called an emotion for a character, right? And an emotion is a very abstract concept, but all emotions fall under some different things, right? They probably reside in your brain or your heart, or whatever kind of way you want to contemplate emotion. But they all have maybe a type, maybe a particular kind of emotion. Maybe they all have a cause that is on your body, a biochemical cause that it would, when you execute that emotion, would make something happen. But then we're not into it yet because we haven't even talked about inheritance yet, but the idea is you have different kinds of emotions. So you might have sub-emotions, or, rage, hate, anger, love, happiness, all that kind of stuff. But the idea is that they all share common features and functionality that they would all use together. But we'll get more to that shortly. In theory, you're supposed to request things in object-oriented programming. That's why if you ever taken a standard Java course, entry-level course, all you did all day was write getters and setters, right? You wrote get value, set value, get methods,
Set value.
set,
Get methods.
yeah,
Set
over and over and over again. It's a giant
over and
pain
over
in
and
the
over
rear.
again. It's a giant pain in the
Oh boy, you need to be
Cool,
careful.
thank you.
An object's internal state is meant to be encapsulated. It's invisible from the outside world. In reality, in many different languages, we don't do that. We expose things to make it easier to work with, to make it easy to access, as well as to speed up performance in some cases. In fact, many classes that you find in Unity are actually not classes, they're structs, because a struct is inherently different, as you'll find out, from a class, and it also adds some performance boosts from time to time. But what you see here is an example of what you might write. So let's say we have a class, an object called stats. Stats is the statistics that tell you how good your player is, right? If it's Dungeons and Dragons, it's your little cheat sheet, right, of all your stuff. Or if it's a game you're playing, it's your power, toughness, HP, magic, and whatnot. You would create this stats object and give it a name. And then in C#, you're going to be using the new keyword a lot. If you're a C person, you're interested in a malloc and whatnot. Here, new is pretty much how you're going to be creating that instance of that object. And then we create our stats, and then you provide it some parameter list. Don't worry about what those parameters are. It doesn't matter. Just notice that you'll be providing it some kind of an input so it populates itself with that information and data. And then here, we would create maybe some different properties here. We have maybe, this should be like more than one line. I'm not sure why I did it this way, but vec get power, you would return the power of that object, or get toughness, or increment the power. You call methods to handle the value stored within it. Like I said, you're supposed to do that. Most of the time you don't. You end up just directly accessing things either for ease of use, or because you're lazy, or for performance reasons. But you can also provide methods and functions to do the same thing for you. And the great thing about doing that is you can protect things. You can keep things from falling apart if someone does something bad. Okay, so let's continue on. Why use it? It allows you to emulate reality. How parents and children, objects, things holding other things, things encapsulating things, containing things, things inheriting from one person to another. All these concepts we are familiar with from being human beings who live in the real world, and we can use all those concepts in programming to organize things very easily. Keeps things in a single package inside of a class, inside of an object, a blueprint of what that thing should actually be. It allows us to reuse code. I don't know about you, but when I was in high school and I was doing programming, I was horrible with reuse. I would rather duplicate the thing and make a few lines of code change rather than figure out how I could make it an abstract class or a class that I could reuse functionality. So if you adhere to OOP, you will be able to reuse and override things when necessary. It's very valuable. Variables also have names, and it makes it so you understand it. And the classes they reside in have names. So you'll be able to understand that when I talk about a heart and I'm talking about the class dog, that it's a dog's heart that I'm dealing with, right? As opposed to a person's heart. Whereas if you're dealing with just a giant collection of variables, and there are ways even in other languages of consolidating them, of using definitions and compiler changes and so forth to name things to other things if you want to, but it's just an easy way for a human to understand things. Hierarchies of organizational information, incredibly important for people. The idea is you can collapse that hierarchy and think of it as one big object, or you can expand it and understand all the details within. Finally, restrictions. This is the most important thing, at least to me. The reason for that is because these days we're never making code for ourselves. We're making code for someone else. We're always designing systems, and as engineers, you will be designing systems that other people will use. You need to restrict their access to things. You need to define the interface, how they mesh with your code, the things they are and are not allowed to do to allow for proper use and not improper use. So why is it hard then? Why do so many people have a problem with object-oriented programming? And part of it is just because we don't want to deal with it. It's a bunch of things you got to learn, and you really, when you're in a class, you do very simple, basic examples. But as soon as you work with a couple other people, as soon as you work on a big project, months at a time, you start realizing how important it is to organize things and how object-oriented programming can save you time and time again a lot of effort. So one thing that's hard though is actually decomposing something. So you have an idea for a game, right? In a post-apocalyptic world. How do you decompose that into classes, into objects? How do you know it's right? That's a daunting task and it can really scare people. And that's why when we're doing decomposition, when we're trying to figure out, okay, what are the fundamental structures I'm starting with and how do I build up from them? These things most people will think about. Encapsulation, what gets stored inside of a class? If I make a human class, do I need to store the inventory inside of them? Is it something that's literally inside of them or not inside of them? Is it something that they access elsewhere? Is there a manager that has nothing to do with it? Granularity, when do you stop? So if I define a human being, do I need to define subsystems? If I have a combat damage system, right? Do I need to define sub-items, sub-limbs, internal organs with physical locations that need to get attacked? How do those systems react to one another? How are they managed? How far down do you go? When do you get to your atom, right? Which wasn't the smallest thing, which is wrong name by when they called it that. But the idea is, what's your indivisible part? What is the smallest part that you're working with? Dependency. What do we rely on? Do we have other libraries? Do we have other classes that we rely on? Can we split our code up into different segments, right, based upon what they rely on? Or does it have to be this big monolithic thing that we're stuck with? That you can't just cut out a couple classes for another project because you've created so many dependencies on everything else that you can't break it apart. And that is bad design, and we'll talk about that shortly. Flexibility. Abstract versus understandable. Usually the most flexible things are highly abstract, vague concepts that will lightly hint at what it was really meant for, but it's gone through so many design revisions and changes and flexibility that it no longer resembles what you were originally trying to create, like a square or a circle. You know, you could abstract them into a shape class, right? And a shape could be just about anything. So maybe you put how to define the area or the perimeter or the circumference in the shape class, but the circle or the square or the rectangle class would actually fill in how to do all that stuff individually. Performance. If you've never done a hardcore C++ course, I highly recommend it so that you learn how object-oriented programming is implemented behind the scenes, because they do not shy away from it. They explain to you the virtual tables behind the scenes, how pointers link from one thing to the next, how you have to go from virtual table to virtual table, when one table overrides another table and at what times, and the overhead associated with just generating a class. So there is performance overhead. We're never going to get away from that with object-oriented programming, but the idea is we gain so many benefits. We are able to speed up development time so much that it doesn't matter as much. Evolution, preparing for the unknown. You don't know what's going to happen tomorrow. You don't know what kind of environment your code is going to find itself in. You don't know what kind of weird display device will come out a year from now and someone's going to try to put your game or whatever you've created on it. You need to try to future-proof for that. And then finally, reusability. Can I use it again? And once again, we kind of already talked about that with the idea if everything's dependent on itself and everything else, you can't really reuse it, because you might want a single class you made that kind of talks about vectors or maybe some cool math stuff that you did. But if it's stuck to a whole simulation thing that you just can't rip out of it, you know, what's the point? It's more work getting it out of there than just rewriting the class. There are wonderful textbooks out there on design patterns that you can get. Some of the best ones are actually made by some folks who originally designed the C++ language out there. And it's actually recommended reading or required reading if you want a Blizzard interview. Last time I checked their job website. So I highly recommend you check them out. They give you some wonderful fundamental understanding of different design patterns that you can reuse over and over and over again. So classes, right? It's a data type. It's an object. Keep those terms in your brain. But most importantly is it's a template. And I'm hoping for most of you, I'm just, beating a bush here. You've already heard all this stuff. But the issue is that every year I teach, I get one or two students who are really hardcore into just maybe the embedded design. and they really didn't pay attention in any OOP class. And they don't understand that the class is not the object, is not the instance. That is the thing that's created. A class is a design. It's how you are designing. It's where you're telling the computer, this object is how you build it. These are all the variables inside of it. These are the features and functionality it has. These are how you work with it. But it isn't the actual thing. It's just telling the computer how to make it. That's incredibly important to understand, because most people in their first few assignments try to work with the class itself and not the instance. That is, they work with the blueprint and not the actual car. You know, if you were using a blueprint to create cars, each car is an instance. That car is what can drive you around. It's what can do work. The class just creates the cars. There are caveats to that, class variables, class methods, and so forth, but let's not go on that too much right now and confuse you. So yeah, it's a blueprint. You get the idea. Instance, attributes. They call them attributes. The terminology in C# might throw you a little bit here and there. You're probably more familiar to instance attributes being just variables in other languages. But the idea with an instance is that the class tells you how to build it, and when it's built that object, you now have unique individual variables inside of that class. So every single car you create is unique to every other car you make. And you can change its values to be anything you want to, and it will not impact any of the other cars that you've generated. So here we have a class called building. Don't worry about how I made it. It's just a class, like everything with programming these days. You don't know what's in there. It's a black box. You just know it's a building, and you know it has certain features and functionality that you can exploit. So here we have building. Building 1 is equal to new. And here we have the building here. This would be called the constructor for the object. It creates the object for you, and you pass it different parameters. In this case, the first parameter tells you how many stories tall the building is. So here we have another building we created, and this time we pass in a value of 2. So it's 2 stories tall. Then we have building1.getStories, a method we would have created that returns to you how many stories it has. So it would return the value of 5, and it would return the value of 2 in both of these cases. The cool thing about that is building could do some amazing things. It looks simple, but when you said get stories, for all you know inside of that class, it could have been creating an entire 3-dimensional model procedurally of that many floors and generate a model for you right there that you can work with. And that's the great thing about classes, is it can encapsulate a lot of features and functionality into something incredibly simple. This keyword, let's see, yes, I know I'm sharing this screen. Can you go away? How do I get, whatever. This, okay? People usually like to think about it in terms of pointers in engineering, from what I've noticed, and that is, a pointer is the memory address, right, where something is located at, and you can use the pointer to access the different elements of it. So this is that instance. It is that, you can think of it, it's not really a pointer, but you can think of it as a pointer to that object. So you're handling this particular object. We use this to refer to the instance that we're operating on right now. So when you're coding your class, very often inside of your method, you'll be typing this dot and then something that the class has that you want to work with. I exploit the use of this everywhere. I like it because when you're working in Visual Studio and you type this dot, it gives you a list of everything that you have access to that you can work with. It makes your life a lot easier. You don't have to memorize anything. You just look at the list and you're done. So use it as much as you can. And don't worry about the fact that you're calling this dot, because compilers usually optimize everything to remove all that stuff anyway if necessary. So don't worry about anything. Here's an example. We have a class named building with a function method called build. So here we've defined a public class, more on what public means, but here's a class called building. Notice curly brackets. And then we have inside of that a variable, right, an attribute called stories tall, which is 1. And here's what was happening when we called that. Here we have building, our public building. This is our constructor. This does the job of building it. A constructor is not a method. It is not a function. Do not confuse the two. All right. You'll notice that there is no return type, not even void. It's not there. A constructor is not a function or a method. It's a special thing used to generate the object. Don't get confused. Then in here, I use this dot stories tall, because when Visual Studio, when I type this dot, it automatically shows me stories tall. I can hit enter and not have to type anything. And it makes it look like I'm a lot faster at typing than I really am. And what I do here, though, is this one, this refers to the instance inside of the class. you'll notice that here I'm using the same name, but it is referring to the parameter that's passed in. This is commonly used many, many times across many developers, because this way you don't have to come up with names for things. You use the same name, you just make sure you're referring to the correct variable by properly using the this term. All right. This way, because what do people do? Oh, well, what if I do stories tall, right? I capitalize the S, but now you've capitalized it. And maybe you use capitalization to refer to, I don't know, class names or function methods. Now you're confusing people because they thought they were dealing with not that, a variable, and instead you're capitalizing, you've messed up everyone's day. So don't do that, is all I'm trying to tell you. Inheritance. Inheritance allows for code reuse and grouping of similar types. Child classes. Inheritance. The idea is that you can take code that's already been generated, created, and reuse it for your own personal gain. A child class can inherit code. It can override, that is replace it. By the way, I'm using the keyword override instead of replace for a reason, because override is a keyword in C# that you will see. And of course, you can add new code if you want to on top of it to give it new features and functionality. And a parent class can control access. So we saw the public earlier, but you can have private, public, and protected. Private means no one's touching this stuff except for me. There are no friend classes like in C++, if you're familiar with a friend class in C#. So you can't get access to someone else. If something's private, that's that. Then there's public. Hey, everyone can have this. Anyone can access it, can see it, it's fine. And then you have protected, which means only child classes of that object are going to be able to access this particular data type or method. Usually, by the way, the default type in C# is private. So if you don't type anything, it will be private. Usually what I'll do is I'll set things to be protected early on, and then I'll go back, and if I want to make it private, so be it, but at least it's protected so I know it's not exposed and out there to everyone else. Define requirements. You can also define a class to be abstract or an interface. We're going to talk a little bit more about them later on, but these are two important concepts that allow you to create templates. Don't confuse them with C++ templates if you've ever used templates in C++. But these allow you to create almost a template that people can use. And actually, in many of the languages, and actually if you do Android programming and several other things as well, they use abstract and interfaces to allow you to work with their systems. And we'll show you a little bit more soon. So let's do an example really quick. Hopefully this is all making perfect sense. Lecakes, will grad students receive extra assignments? Oh, I'm sorry, Mohammed, I did not reply. Next time, feel free to just interject with a question like that if you notice I'm rambling. Yes, you will get different assignments, or if the assignment is not different, or that is, you may get more assignments, but what you will certainly always have is the assignment that is given out will have additional grad level requirements on the end that are above and beyond what the undergraduates will do. So in the past, I had as an assignment, people had to make a Minecraft chunk all through code. And the graduate students had to take that much further and implement more complicated things like voids or different textures on the surfaces and so forth. That's an example of an undergrad just doing the chunk, the block, whereas a grad student needing to make it more advanced, maybe optimizing it, making it so that it removes redundant information that's not necessary. Those are the kinds of things you'll be doing. You'll be doing what the undergrads do plus more for the most part. Okay.
All right, thank you.
No problem. So let's decompose a player. I've got a player in my my new game that I am marketing out there. I'm using games because people like games, but hopefully you saw from that first lecture that games are not something I normally do. Okay, I'm doing more engineering and application and real world things, but games are fun. So let's stick to that. Let's decompose a player or an NPC object. We're going to start with the most generic abstract thing we can think of, and that is an entity. An entity exists in 3D space. It literally exists, and that's it. And all we want is for our class entity over here, notice that this is capital. Classes in C# should always be capitalized. Do not make that mistake. That'll be the first thing that I yell at you for. But we'll have different variables, attributes that entity will have. Say, let's see, an entity will have a unique numerical ID, right? An unsigned long ID. Long because we want most likely 64 bits because it's an ID and we want as many values as we possibly can so that in a billion years from now, we'll still have possible combinations that have not been used. The reason for an ID system as well is so that you can serialize your data and store it away in the future. So if everything has a unique ID asset, a UUID, I believe in Java it's called, it's a great way to make sure you can save data and bring it back and never have conflicts. Then, of course, a name. Obviously, every entity has a name, regardless of what it might be. And since an entity exists, we will say it has to have a 3D position. We are not going to get into a deep discussion on if a deity is an entity and exists everywhere and nowhere. We would just give it a nan value or an infinity floating point value or something like that in that case. All right. When a class contains another class, and this is important, it's called something completely different. It's called composition. And one of the most important things for you to learn is when you should use composition versus inheritance. And I will give you an example in a few slides using the Unreal Engine and how if you just keep blindly inheriting everything, it creates an unwieldy class structure that is impossible to reuse or work with. Whereas if you use composition, that is, you contain another object, right? I am an entity, but I might have an inventory. I have one. I am not an inventory. An inventory is not an entity necessarily, but I do have one. If you can say I have something, you might want to be using composition instead. Balancing composition and inheritance, like I said, is a big deal when you get to larger projects. So access modifiers. We already talked about this, so I'm not going to go over it too much, but imposing restrictions is important. In these early assignments, I don't expect you to do this at all. You're probably going to make everything public, and that's because inside of Unity, public variables are visible in the inspector. So you can see the results inside of Unity if you make them public. You don't have to. There's another thing you can use, a different attribute, which we'll talk about, but go ahead and use public for now. Just understand that maybe around halfway through the course, I'm going to start expecting that you've got the basics down now and you'll start making better choices and you'll start actually trying to use some of these things in your code. We have protected. The idea is it's accessible only to child classes, and then private, no one can touch that. Once again, private is usually when you have some nuts and bolts stuff that you don't want anyone else to mess with. That literally makes it work properly. If no access modifier is used, as I mentioned, it's referred to as private. So now we have a class called entity, but we've made some changes, right? We're going to make that unsigned integer ID private. No one should ever mess with our ID. In fact, in a perfect world, no one can except for maybe the class generating it. That is, when it gets created, it gets an ID and no one can touch it ever again. You always have to get a new ID that's never been used before. And then the string, the name, well, for right now, we'll make that protected. People might want to access that, might want to know its name, but maybe we'll provide a function. That way people can't change my name, right? No, we don't want anyone to be able to change your name. That's your name. We don't want people to have access to your social security number or your birth certificate and, Sharpie a different name on there. So we make it protected. And then finally, public, because the position is something that will probably get changed a lot and it'll be moving around. And it might happen so frequently that locking it away behind a method call or function might cause some performance issues. But also, we might have a lot of other classes that are constantly changing your entity's position. Collision systems, managers, other things picking you up and moving you, right? Maybe we want them to have direct access. These are just some examples, okay? Don't 100% stick to them. They're just reasons why I chose to make those particular restrictions there. So here we've got a couple restrictions. Only entity can change the ID. Non-entity classes can't affect our name, but child classes will have access to it, and anyone can mess with the position. And these choices do have long-term repercussions. So when you're coding something, think about 20 years from now. Hopefully someone's still using it, but it could very much change how they work with your system. Getters and setters. C# has its own way of doing this, but this is very popular. The idea is that you create methods or functions that allow you to have access to the different variables. So getters typically say get whatever the variable name is. In C#, functions, methods are usually capital, as you can see here. And I use, camel case, where every word will be capital after that. I only use underscores when I need to break terms, in case you're wondering. Here you would then return the ID of getID. In C#, you actually have what are called properties. I am not a huge fan of properties personally, if you're familiar with the C# language. It's a way of really speeding things up, but I find that sometimes you get confused as to what's a property. That is what's sort of a sped up way of getting or setting something versus what's truly a method or what actually is a variable. You just got to get used to it. Don't worry about it. We will talk about that later. I just want to let you know that you could create something called like capital ID instead. And this would be called a property, and you can set it equal to something, or you can do operations on it and so forth. But the idea is it wraps up the whole get set thing automatically so that you don't have to write a bunch of redundant code over and over and over again. And let's continue with our example. So entity is very basic, doesn't offer much at all. For gameplay, let's add some complexity by using inheritance. That is, we're going to reuse what we already have. Let's create a child class called a mortal. A mortal is anything that has a life, that can live and die. So obviously an entity could be a rock, but a mortal will be a frog or a pigeon or a dog or a mycelium or whatever you want to. Mortal means therefore that it is living and it may be able to die. And we're going to add on top of that existing functionality of entity our life or death code as well. I have a note here. Inheritance with graphs. In case you haven't messed with these graphs much, arrows point to the dependent thing. So a mortal is dependent on an entity, therefore the arrow goes that way. Logically, though, for a lot of people who aren't familiar with these diagrams, we always think of things going the opposite direction because it's like, okay, the data is flowing down a tree, down a hierarchy to these things. But no, the arrow points to the dependent thing. Make sure you memorize that. It'll make all these charts make more sense. So mortal is a type of entity. And here is where the difference between inheritance and composition becomes important. If something is something, that's inheritance. If a frog is an amphibian, if a mortal is an entity, we are using inheritance. That is a key to you that you're using that or that you should be using it. If you say, though, that X has something, that is composition. That is where you're pulling things together to make you're pulling different components together to make something. Okay, and it's very important to distinguish those. I might be a mortal, but I have an arm, I have a leg, and I may make separate classes for each of those and have them inside of a mortal instead. That way, a mortal doesn't have a ton of code for every single subsystem inside of my body. Each of those subsystems are several classes. My body, the mortal, just happens to have instances of each one to work with. That encapsulates the ideas into individual units that are easier to work with. The class mortal adds, we're going to add with this class an unsigned integer, a uint, for hit points, an unsigned integer for current hit points. I'm using a lot of unsigned int stuff and terminology like that because I believe most of you are engineers. So those are terms you'll be familiar with if you had Mulbire or who teaches it now? Russell. Russell does a lot of it, and Tang. These are terms you're familiar with. That's why I'm using, typically in C#, no one's caring about unsigned anything or whatnot. They just use a big old data type that they can and make it work. But we can do better. Then we have a method we add called bool is alive that we can check and call to see whether or not the thing is alive. Is alive will return true if it's alive. It'll do an internal check, just look at the current hit points to do a check against the total hit points that it should have and see whether or not that's equal to 0 or something, and then determine whether or not you are alive. Terminology that you need to know: base, super, parent, classes. That's the entity. That's the top one. That's our base class, the beginning of everything. Derived, sub, or child classes are the mortal class. That's everything coming down the line. Everything you work with in C# is going to be a derived, sub, or child class. That's the essence of it for the most part. Inheritance example. So we can create lots of different mortals, but we need to make them carefully. So for instance, we might make a generator class, and this is a pretty popular concept, and whose goal, whose entire existence is nothing but creating mortals for you, right? So if filling in the information for a mortal is tedious or complicated, I could make a class called generator, and these are most likely going to be static methods, but the idea is that generator.createHuman, and you pass in a name and it will automatically fill in that class with all these different stats, right? That makes a human specific. Same thing with create slug. A slug is a mortal as well. You would have a method that would do this and generate it by filling in the appropriate values. But that's kind of completely glossing over an incredibly important part of object-oriented programming, and that is we could, instead of making a generator that fills in all these slots for us, instead we could create just child classes of mortal, one for human and one for slug. And those are responsible for setting up the values for us automatically, rather than a generator class doing that for us. Both are permissible, both are possible. It's entirely up to you and how you want to code things. But here, I'm trying to show you what the code is going to look like when you start typing in Unity here. That's why these are all pretty much how you would see them when you're typing in your IDE. Private, and we have a list. These brackets here indicate the type. If you're familiar with a lot of languages, especially higher level ones, a lot of times they don't have a type for arrays or lists. You can put whatever you want to in there. It doesn't matter. You're not strongly associated with a specific size. These are specifying that this list will only hold a object of type mortal. Okay, so you can put any mortal you want to in that list. All right, and here we have the two different methods, mortal create human and mortal create slug. And as I mentioned, we're stuck with just making this generator class larger and larger and larger. Another way of handling this would be using inheritance again, creating a subclass for human and a subclass for slug. And each of these in its constructor, or in where it sets it up, its initialization, would put the right values in there automatically for you. Okay, and then of course you could continue to extend, human to being different types of people, from all over the place, and give them each their own individual properties and values and so forth and attributes. You can extend and extend as deeply as you want to. If you want to design something though for the future, carelessly just making a class longer and longer and longer and longer and longer is going to have some design ramifications. It's going to take more time to compile. It's going to become a mess sometimes to work with. Not only that, but you might require certain features to be available to other people. And for that, rather than giving them your class and your code to inherit from, maybe you just tell them, hey, you want to talk to me? You don't need to know how I do anything. All you need to understand is that these are the methods that you need to have. I will call on these methods at the appropriate time. You make sure you have these things and we're good to go. You and me, we're solid. You don't need to worry about anything. And that's where we deal with interfaces or even abstract classes. So let's imagine that we have a class called Combat Manager. Whenever I call something a manager, understand it's going to be a little higher level. It's going to be handling something that routinely happens in the game. It's going to be dealing most likely with multiple objects, and it's going to be handling interactions between them. That's what a manager usually does. And in many times, if you're familiar with the concept of a singleton, that is, you'll only have one of them in your code running at that time, you'll only have one of these managers, but you don't have to. Sometimes you'll have more, it depends. Right now, we'll assume that we'll just have one. But the idea here is that Combat Manager is going to handle combat between two mortals. Handle combat is going to be a function we create that's going to take in some parameters. But handle combat, in order for handle combat to work, in order for Combat Manager, which I'll call CM, to work, right? It assumes whatever it gets past, any object that can do combat, any mortal, or whatever we'll call it, it has a method called attack, right? I don't know why I'm doing this. I've got a perfectly good pen right here. And defend, right? We have to make sure everyone has that, all right? And it's going to have different parameters. It has to take in a target and it has to take in damage. Okay, we need to guarantee in our code that if you want to work with us, you've got to have this stuff, okay? Now, you could just be like, please, but no one's going to listen to you and everything's going to break. So how do we impose this requirement? We impose it. Do I actually talk about how I not? Okay, I'm sorry. We'll get to how I impose that in just a second. Let's just look at this. This is actually me showing you kind of how the combat thing would work. Here's your class right here, Combat Manager. And I just threw this together really quick in Unity. But the idea is that you have that list that I was talking about, right here. So it's going to take in combat tasks. And I got a little over the top with this while I was thinking about it. But a combat task is just another class I created. Once again, you just you have an idea, you have a concept, right? Just make it a class. Throw it in there. If it's not performance good, then you change it to something else, maybe an enum or something else, right? But I had this idea that I'm going to be iterating over attacks. So I shove the attack in a task, right? And the combat task is going to hold who's doing the fighting, the assailant. It's going to hold multiple targets, an array of targets. Why? Because if I'm making a game, I'm pretty sure I'm going to want like single target, multi-target stuff, area of effect stuff. So that's got to have an array probably, right? And then an enum of combat type. What is that? I don't know. Maybe you have combat with fighting with fists or weapons or something. Those are different types, right? I'm just taking an idea and I'm abstracting it out and I'm just seeing where it goes. I'm just playing around. Then we have public void add task. You will add tasks to the combat manager. Each of these tasks completely describes everything necessary to make a combat event happen, right? It stores the assailant, it stores everyone who's going to get hit by this person, and then it even tells you how they're going to do the hitting. And of course, even that could be an array if you wanted to, and you could iterate through each one. But the most important one here is handle combat, right? So handle combat is going to take in that combat task right here. It's going to do a for loop, and I'm purposefully using a for each here so you see that as an example. That in C# we have two for loops. We have the traditional C or C++ style or Java style, which would have the three elements with the initialization, the conditional, and then finally what you do after the loop has concluded. The typical for loop. But then we also have for each. For each is about incrementing over every single element within that list, that object, and working with that. We also have this thing called var. I'm trying to throw stuff at you so you get a taste for this stuff. var is for lazy people who don't know what the variable type actually should be. That's what var is for. var means let the compiler figure it out. We know exactly what that task is. It's a task. It's right here, task, combat, task. I could have written the type task or int or float or whatever the type would have been, but you will see var many times in examples online. I want you to see it here so I can explain it so you can understand what's going on. It just means fill this type in at a later date by the compiler automatically. And then we're going to iterate over all the combat tasks in combat tasks. Combat tasks, once again, up here at the top, that's our list. We're iterating over every single one inside of there, and we're going to handle all of the combats that we've decided to handle for this round of combat. Then we're going to iterate over, once again, double for loops. Get used to them. Just about everything you do is going to have multiple loops inside of loops inside of loops, okay? The Minecraft example that I had students do last year had a triple for loop in order to deal with three-dimensional data. This isn't always the right way to do things if you deal with parallel systems, but most of the time we'll be dealing with serial, sequential things. So double for loops, triple for loops are just fine. But here we iterate over every single target because remember, we could be attacking multiple things, and we do task.assailant, that is the person doing the damaging, .attack, and then we have it attack its target, right? And then we do target.defend. What's important here? And of course, I've got the, let me pick a color that doesn't clash with everything I'm doing. Let's do green. What's important here is that I'm assuming every target, every one of these things that gets passed in has that method attack and has that method defend. So the first way we can handle this is by using what's referred to as an abstract class. The idea behind an abstract class is, as the name tells you, it's abstract. It's not complete. It's ethereal, right? It's not finished. Parts of it are missing. If you've got a class where you need certain features and you need maybe variables along with it, maybe some parts of it are filled in, but you need some parts to be open. That is for someone else to fill in. Then you want to make it abstract, okay? So in this case, we've got a class mortal that I've now made abstract. What does it mean when it's abstract? One of the most important things you need to understand is that you cannot create an instance of an abstract class. Not allowed. You'll get an error, okay? That's the entire reason it's abstract. It means I didn't finish this. You need to finish it for me, okay? You finish this and you can use it with this entire system that I've created, because in all the software you'll be working with, other people have struggled for years creating highly efficient managers that do specific tasks, collision detection, rendering, physics setup, all kinds of different stuff. You are working within their framework. So they are giving you the framework to work within. You need to implement it and fill it in so that it knows what to do at the appropriate time. In this case, all of you could make your own mortal now if I gave you this mortal class, and you would fill in attack and defend. So if you make a fire-based pixie character, right? Maybe its attack would be fire-based. I don't know. That's for you to figure out. That's for you to make my game better. That's for you to mod it and add new features and functionality, right? It's not for me to deal with. I'm just giving you the system to work within. Importantly, it enforces people to work with your code in the proper and correct way. It gives a standard, so to speak. It is an interface. It's how you interface, lock together, make things work. Okay? So remember, by making it abstract, we can no longer create mortals. I cannot do new mortal. I have to create, that is, I have to create a child class inheriting from mortal. And that child class, so long as it's not abstract, can also be created in the future. So here, this is kind of what we got here now. We've got an entity class, which is our base-ish class. It's not the true base class because C# has a real base class. But to us, it's our starting block. It's the crux of everything. Then we have this abstract mortal class, which contains everything an entity has, but adds that concept of life and death. But that's where we ended it. Now we're giving this code to our underlings, right? Our grunts on the project, you know, the new hired interns who have to implement all the stuff the creative director wants. And the creative director, I want a human, I want a slug, I want an orc, I want this other thing too. It's changing every day. It doesn't matter how many times it changes. The cool thing is the entire combat system will always work so long as the new creatures you create all inherit from mortal and implement attack and defend. Because the combat system will call attack and it will call defend regardless of what the thing is, what code you put in there. And that's where you got to be careful because there's nothing stopping you from putting an infinite loop in there and breaking everything. So it's giving you the keys to the car, all right? So long as you know where to put the key and everything else for that matter. And here I think I gave you a couple little examples of what this might look like in Unity. You've got some new variables. A human has experience points. Human might have strength. And their combat is based upon these properties that are unique to a human. We return the experience, how much wisdom they have, time, not wisdom, experience is different, but how much experience they have in combat by their strength. And then here we defend them by clamping, using the clamp method. All the mathematical operators that you're familiar with in all other languages are available to you in this one as well. Here we use a clamp to make sure that the amount of damage we get is the damage minus your strength, and we always make sure that we never get a negative number in there. That's what the clamp is for. And then a slug, though, a slug is a completely different beast, right? So here we're using the ternary operator, that lovely little question mark with the colon on the other side to choose between two different values. When a banana slug attacks, or that is, when a slug attacks, we see whether or not it's a banana slug. I don't know why I did that. I just used that because it's silly. But the idea is if it is a banana slug, then it will deal 10 damage. And if it's not, it will use 1 damage. Here in defend, completely different. Here we take the damage, we convert it over to an integer 32, and then we use whether or not it was a banana slug to deal how much damage. Why did I have to do all that nonsense? I'm showing you an example where in lower level languages like C or C++, you might be familiar with just casually converting a bool to an int to whatever you want to and letting it fly. That stuff don't work in C# or Java. You need to convert it over to the correct type. So just, I'm warning you now, when you try to do that stuff, expect that you'll need to look up, okay, how do I convert from one thing to the other? Most of that stuff is either in convert or the class itself, like in32 will have methods to convert from one type to another. Just understand you're going to want Google or another browser open so you can look stuff up. Okay, the bubble up effect. So I spent a lot of time, and I really hope it was valuable and you learned something new or I refreshed it. But why does this matter? And this is in a great book that I have called Real-Time Game Engines. And this came out around the time of, I'd say, Unreal, not 2004, a later edition. But it was talking about how they designed the class structure inside that engine. And what they did was they had this thing, and they call it the monolithic class structure. And everything depended on these subclasses. And when they wanted to add a new feature, and it seemed very generic, they said, oh, well, you know what? Rather than just having this feature be a one shot, or something that maybe it could be a composition. It could be contained by another object. Well, you know what? Let's take, for example, vehicles. Well, we've got a vehicle and it's going to inherit from all this stuff. So we have actor, we have brushes, controller, AI player. So many, many, many levels. Here we have pawn, we have vehicle, but we want to make a new kind of vehicle. We want to have an amphibious vehicle, right? Well, to do that, an amphibious vehicle, what? Floats, right? But you know what? Technically, everything in our game could float, right? So long as it's an actor. Think of actor as an entity in this case. You know, it has a physical location in the world. Everything should have that floating property, right? So now, all of a sudden, things in your game that were never meant to float now have the option to float, which is cool. But at the same time, all of your objects are now taking up that much more memory. They've just gotten that much bigger. You know, and if this happens enough, all of a sudden things bloat, they get huge, they become unwieldy, and it's just a mess. And it also becomes impossible to remove those features later on, right? You want to reuse this code and you're playing in a space game that doesn't have the ability to float because you're flying in the cosmos? Well, crud, that's in your base class. You're stuck with that feature. So this is why you got to be careful when you're doing this. And what I hope you get out of this lesson is to think about what you're doing and understand it's going to have cause and effect scenarios later on. This is something we do not have to worry about in C#, but they make reference of it in the text called the deadly diamond, and it's multiple inheritance. You're not allowed to do this in most recenter languages, but C++ and some other language will allow you to do it. The problem with doing multiple inheritance is, if I'm inheriting from multiple things, they all have to get set up in a sequential order. What if one overrides the other, right? Which one actually gets set up? You know, which one in the order? I have to be very careful about how I decide to inherit from different things. In this case, we're talking about a vehicle. Well, okay, let's make two subclasses. Here we have land vehicle, so it's only driving on the surface, right? And we have a water vehicle, right? And that only drives on the other thing. Well, you know what? They each have cool features. Well, why don't we make the best of both worlds by just creating an amphibious vehicle underneath of it and inheriting from both of them? But remember, both of them also inherit from vehicle. So land vehicle initializes vehicle, water vehicle again initializes vehicle. Do you kind of see the problem? And technically, you could provide different parameters to vehicle in land vehicle and water vehicle. So what do you end up with? Don't deal with it. This is called the diamond of death for a reason. Stay away from it if you can, okay? And this is why we use interfaces. Interfaces are everywhere in Java and in C#, and interfaces are even in C, but you have to carefully design them. You make functors and functional pointers and whatnot, and you specify the types. But the idea of them is deeply embedded in these OOP languages that we see nowadays. And the idea is, instead of making an abstract class, remember, an abstract class is a class, right? It can have variables, it can have code, and it can have methods that are not filled in. The difference with an interface is it doesn't have any of that stuff. It's basically a contract, a promise. It simply states that, hey, if you want to be X, Y, and Z, you need to fill in these functions. You need to have these methods. And if you have them, great, I can work with you, okay? So interfaces are used to define a contract, okay? And these things have to be defined if you want to implement it. And luckily in Visual Studio and most IDEs, it will automatically give you a warning when you try to implement an interface and tell you you have not implemented the following methods and functions. Please do so. And if you click on a little drop down, it will auto-fill them in for you, and you just replace what's inside of each one. So what we could do is we could move the combat manager's required functions into an interface class instead, so that any class could become a combatant. You could make a rock, which is not immortal, still work with the combat system, right? That's true flexibility right there. So in this case, we have public interface combatant, public int attack, public void defend. Those are the methods, the properties, the methods, the functions we have defined. But what you notice is I have a semicolon at the end of it, because all I've done is I said, these are the functions we need. I don't know how to implement them. That's up to you, because you want to work within my system. And then now in public class human, you'll see I have a colon. This is indicating now that we're dealing with, okay, we've defined the class name and its accessors. Now we're defining what it inherits or what interfaces we are going to implement. That is a key word to write down, implement. You implement an interface. You inherit from another class. In this case, we are inheriting from one thing because that's all we're allowed to do. We're inheriting from mortal, but we are allowed to implement as many classes as many interfaces. I called it a class. Don't, I messed that up. We are allowed to implement as many interfaces as we'd like. So here I can implement combatant. I could also, if I made another interface for the physics system so that it knows how to work with it, I could make a collider interface and add that to it, and more interfaces so that it can work with all these different systems. And hopefully you see the value there, is that you can keep adding these requirements onto this class. And the great thing is I can always strip them off, right? I could throw them away if I don't want to, and I can reuse it. It's a little bit more flexible in terms of being able to work with it. So just once more, abstract class if it needs to be a class for some reason. That is, you have functionality or features that you've already spent a lot of time creating, and you kind of need to dump all that data into something else, but you need them to fill something else in. It needs to have variables declared inside of it. It needs to have some code that's already implemented. And child classes don't have to inherit from anything. Will not require any other classes for inheritance in this case. The interface, though, does not need to be a class because it's not. If you looked above, notice how I said public interface. It's a different keyword, right, instead of public class. Has no variables or methods defined, may need to be included alongside multiple other things that you need to implement. So in Android programming, for instance, you implement different interfaces that give you functionality to work with different subsystems like Bluetooth or other things for that matter. You implement that interface and now you know how to work within that framework, okay? And the right things will happen because you have told it, I can do these things, you tell me when to do them and I'll make it happen. All right, so that's it for the OOP lecture. If it's all right with you, I'd like to take just a quick like 2-3 minute break, go to the bathroom and so forth, and then we will talk about C# from a higher level. We're not going to go into the nuts and bolts of everything, but I do want to familiarize you all with the language a little bit. I'm not going to lie, you have to code. You need to sit down and code these things to get good at C#. So please spend some time, fiddle with it, try to make some interesting things, break it, and don't get it to work and solve it, okay? That's the only way you're going to learn. Anyway, 5 minutes, say 6:50. We'll all come back, okay? All right. So let's just do a 5-minute break. I'll make a splash screen for the next class. Return at 6:50 p.m. Okay? All right. Be right back, everyone. I'm going to mute myself because I have kids in the background that have been very quiet. Very good, actually. Let's see. So the question is, how do I mute myself when this is going on? All right, we still got a minute, so while we're waiting for everyone to return, I thought I would share one other thing really fast. Let me stop. So I actually had an example I forgot to mention to all of you that I just did last night. So the kinds of stuff you can do once you've gotten good at things. This is a 3D printed mask that I literally printed last night for a project for the art studio at Rowan University, and they're going to have an artist come by, even with COVID going on, to have an open gallery exhibit. But what they needed to do, and the reason I have an Oculus Go right here is not because I actively develop on it. No, that's not the reason. The reason is because we're going to be using this to deploy their art gallery piece. And the idea being the artist, I'm not the artist, guys. This is someone else's ask, not mine, because I don't think it's a good idea. But they wanted this 3D model that they gave me to work with this as something to be on it. So I shelled out the entire thing. So it's a good reason to know some 3D modeling applications at a low level, not just CAD, but actual polygonal data. And I ripped out all the insides. This used to be all full. And I created an insert for the Go by measuring it. And that pops on there so that it attaches. And I took that insert at that point, fused it to the interior of the mask. And now I have a slot that I can shove it into and then, we're on my face or whatever it is. Like I said, that's what they wanted. And I'm not going to question it. I'm not the client, it's someone else, and you don't question the client. So that's what they wanted. But yeah, I did that over the weekend. So once you've got your skills down and you know a little bit about things, you can just start making stuff real quick. Okay. So before we continue, does anyone have any questions, concerns, thoughts, anything? Because no one's really spoken up. I just want to make sure we're all on the same page. Okay, good. All right, so before we jump into the last bit of lecture material for today, I did want to take a second and talk about Unity and Hub. And for those of you who haven't done things, just make sure that you're on the right page, that I'm giving you an option, because many people are introverted and they don't want to ask questions unless prompted. So this is Unity Hub. Hopefully you all have it installed. Today, a new update launched for 2.4.0, so you might want to update to the latest one. It will list your different projects, and of course, hopefully by the end of tomorrow, what you have done is installed this. You will have an installation of 2019.4.x. I have two different versions. They keep coming out with new ones. Don't worry about the end number, the .6F1. These are all bug fixes. That's all this is. So long as it's a 2019.4 something long-term support, just continue with it. We'll all be able to work together, but you have to be using that. The great news behind using Unity Hub is you can have multiple installations, but you'll want to go to add and then just choose whatever the latest one here. Here, they already have .10 out, 10F1. A few weeks ago, it was .9 when I was recording some videos, and before that it was 6 and so forth and so on. So just make sure you're using one of these and we're all going to be just fine with any assignments that you submit. We will not be using Unity 2020. They got that out on September 10th. Which one? .10? Yep, .10. Okay, good. Yeah, so actually, yeah, pretty recently then. And they will continue to do that. They are fixing things. You'll never lose support. You'll never lose capabilities. You'll only be gaining fixes. So always, if you can, update. It's up to you. But the general idea is not to be using 2020. The reason for that is Unity has added several changes to their rendering pipeline. And I have a hard enough time teaching this course without giving you the universal pipeline talk. Okay, it's like literally the grown-up talk you have to have with a kid. So we need to learn the foundation of things first. And for that, 2019 is perfect. You are going to be learning and writing your own shaders from the ground up. The universal pipeline, and through an extension in 2019, you can do this all graphically through a GUI, but I don't want that. I want you to understand how all these pieces actually work and what needs to be generated and created. So we are going to be doing this all by code. In the future, you, with all that knowledge and understanding, you will be a demon. You will be a master at being able to handle all this stuff yourself. Okay. So that's why we're sticking with 2019. Also, 2019 is the only one you can be certified for at the moment. 2020 is still too new. So that's another reason. So make sure you've installed that and you have it running and that you have created a new project as well. When you create a new project, make sure you select the proper version. If you don't beforehand, that'll mess things up. So choose whatever version you want to. Always choose 3D if you can. Do not 3D with extras is fine. It just adds stuff to your to the packages. Don't worry about it. But stay away from the high definition rendering pipeline. Stay away from the universal render pipeline, please. And then these other ones are deal with tutorials and other things. We don't need to deal with any of that either. Those are new with 2019, the new hub, I believe. I don't remember them being there a week ago. But 2D, we're also going to stay away from. The reason, because if you can do it in 3D, you can do it in 2D. There are a few different concepts with sprites and textures and a few other things, but for the most part, you get rid of one of your dimensions and you got a 2D game. So let's not worry about that. Stick to 3D, give it a name, put it somewhere on your computer. Desktop is always good to nuke it. And we're just going to call this example, hit enter, and make sure it can create the project successfully. And I think it's in week 1, the videos that I put out, I actually go into some discussion on what the project directory is and how important it is. And all I'm going to say in this class, because I'll let the video do the rest of the talking, is don't mess with the project directory if you don't know what you're doing, because renaming things or moving things around can be very bad until you get some experience. So please take some time to get used to Unity, and then you'll know when you can delete an entire folder and have Unity automatically regenerate its contents versus deleting a folder and literally breaking your project forever. So yes, you'll have.
Excuse me, Professor Lecakes.
Yeah. Go ahead.
Are you sharing your screen right now? Because I can see it.
Sorry, I will share it right now. Thank you. Please speak up, everyone, because
I
it's
was
hard for me to know
just wondering
when it is. Yes. So so actually, that is a great point. So let's go back and open up Unity Hub. So this is what you should have been seeing. Here is our latest project example that we're working with. Whatever your current platform, that's most likely going to be Windows-based unless you're working on a different one. And then selecting 2019.4, making sure you go to new, first select the version you're targeting, selecting 3D, location, and the name of your project as well. I will go into later on how to properly manage a project because this is a project, but this is a project folder within a larger project, which will be your final project. And understanding how to organize your 3D modeling assets and everything else, and this project internally inside of a larger project structure is important. So we'll talk about that another time. Just create that folder for now. Unity, of course, will then launch, and hopefully you have something that looks like this. That you can see things, and you can follow the short video I have on the different UI elements. That's something that you can do in your own time. I don't want to waste class time describing the play button, the pause button, and so forth and so on. Okay, so make sure you go over that stuff, but make sure that'll open. And then of course, make sure Blender launches. I will admit Blender, I've had issues where people have extremely old laptops. We're talking 6 years old. There are some OpenGL issues with it. They did fix it, but it did require quite a few Stack Overflow-ish forum posts to find what the issue is. But just make sure you can load it up. And I'm using the middle mouse button. Just make sure you can rotate around and things update appropriately. Okay, that's the minimum for the course. And then the last thing too are your substances, Painter and Designer. Or if you have the option of it, I highly recommend doing Substance Source, which is a all-in-one thing comparable to Unity Hub that will keep you updated and have all of your programs in one convenient location, as you can see here. And you can access them through these different panels. In this case, here's Substance Painter. Once again, this is harder to test because you actually need a 3D model. So let's just go to File, New. Have they added automatic 3D models yet? Doesn't look like it yet. But usually what you'll do is you'll need to load up a model And I can give you, if you want to test it, I can give you an FBX file to test at your own to make sure that things load up properly. And you will load up. Is it going to load or not? I have 1 day remaining in my license. Maybe that's the problem. Let's just load anything. We'll do curtains. Sorry, everyone. 1 second. Apparently, it wants me to update my license. So I'm just going to use my current license for now. There we are. Now we can do something. Come on, Unity. Anytime now. I mean, not, you know what? Let's go to Roblox. And let's do a substance painter, and we'll open up a completely ridiculous example that has nothing to do with this course or anything. So this is an example of a Roblox asset. We will not be using Roblox in this class, okay? But anyway, this is an example of creating an asset using Substance Painter for a program like Roblox, and just loading something up, moving it around, seeing that it loads up, that you get the different panels. And here is an example of how you would work in Substance Painter, where you have multiple layers. If you're familiar with Adobe Photoshop or GIMP or anything similar to that, it's very similar, except that it's kind of like Photoshop on crack. You are constantly painting on multiple channels of information all at the same time. Whereas Photoshop, it's color. In Substance Painter, and this is why it will kill your computer, you are literally working with, here we're working with not just color, the base color, height information, roughness information, metallic information, normal information, ambient occlusion information. And if I hit C on the keyboard, you can see I'm iterating through all those different channels of information all in real time. You get to paint these properties onto the surface. So that's why it will completely kill your computer very quickly. But just make sure it loads and works. Substance Designer, if Substance Painter works, Designer is going to work. Just make sure you have that as well. Okay, with that, why don't we jump into the last bit of the class for tonight, and we'll talk about C#. And then I will wrap up telling you what we'll go over next week and what's due and everything. So anyway, Virtual Reality Systems, C# overview. It will be C# with a more Unity-centric feel. Okay, some features you're not going to use very often or at all from C#, so I'm not going to go over them. But anyway, C# versions. This used to be more important, but lately Unity has done a really great job at constantly being in usually one version behind whatever the latest one is. But it's evolved since early 2002. With the very first versions of C#. And in Unity 2019.4.x, which we are working with, Unity supports C# version 7.3. Notice that we're already up to version 8. Notice that C# rapidly gets updates, very rapidly compared to other languages that are more open and have large consortiums behind them. I'm looking at you, Java, which takes forever to have any kind of fundamental change. C# doesn't have that as much, and you will see it very, very, very rapidly add new features and grow over time, as opposed to other languages. That being said, if you do use earlier versions of Unity, you do want to check. There are some features that are not supported. For a while there, earlier versions of Unity was locked to C# 4.0. And there are quite a few features that you just couldn't work with, but that's kind of not the issue anymore, so don't worry too much. The next thing that you need to understand with Unity is that you're working with scripts. And the term script, notice I didn't say code. Notice I didn't say object file. Notice I didn't say any of that stuff that you might be familiar with if you're dealing with other programming languages, okay? A script goes back to the days of MS-DOS, and I doubt any of you, or few of you, have actually had to, as a child, like I did, type MS-DOS commands to play really crappy 2D games. But MS-DOS had batch files, which were just commands in a text file that you would issue, and it would go through the list of commands, executing each one after the other. So that's the idea of a script. It was a convenient way to execute a lot of different commands. And since then, the idea has evolved to become this middle ground for developers, where you have hardcore computer scientists and engineers who are designing the performance critical components of a software structure with low-level languages like C or C++. To use an example, Roblox. Once again, if you're not familiar, I don't know what to say. Get kids, have kids. You'll find out what it is real quick. But a game like Roblox has an entire C, C++ underbelly, and you use a high-level language like Lua to write scripts that bind to that language. That makes it really easy to add features and functionality and to run code in either on the fly or just in time, as some compilers will call it. But the idea is that you create links from this low-level language to the scripting language. I used the example of Roblox because it uses the language Lua, and Lua was literally designed to do this. The language has very few features actually, and most of it is meant to create a very simple ability to take low-level functions and match them to high-level Lua commands and vice versa, so that you can have this scripting language. And that's why games like World of Warcraft, Garry's Mod, and Roblox use Lua. However, on the other side of that, there are very feature-rich languages that are very popular, like Python, especially in the machine learning biz, where Python has been used as that glue, that interface, where it will talk to C++ through functions that you define and that get executed. In this case, Autodesk Maya has a Python backend, Blender does, and many AI systems as well. And that's one of the big problems I have with most machine learning classes is they have you use the Python high-level versions instead of actually teaching you what's going on underneath the surface, which irks me a bit. But the idea is that scripts are letting you use higher level languages that are easier, that can be run and executed just about at any time for really rapid prototyping and development. And that's why C# is used as a scripting language, pseudo scripting language in Unity. I'm going to be careful how I say that. At one time, Unity actually supported 3 different scripting languages: C#, JavaScript, and Boo. Boo died like 6 years ago or something. It's been a while. JavaScript died off, I think it was around in 2017. If you go back far enough in the Unity support manuals, you will see that they had different C#, JavaScript, or Boo sections for every single class, method, and feature. Eventually, they just stuck with C# because each of those other ones really became very restrictive and difficult to do everything that you wanted to do. Also, C# performance-wise is pretty awesome. C# mono behavior. When working inside of the Unity editor, we write scripts, not programs. And I make that distinction very clear in this slide so that you don't try to do this. And every year someone does. Unity, the engine, will handle compiling and building your project. It will take your scripts and build them with its own scripts and codes and files and stuff, and it will generate for you a build, as we call it, an executable that you can then launch. You never create a main point of entry. The game engine handles that. Think about what a game engine does. It's got a lot of work to do, okay? It's a ton of code, and it is building everything. It's the engine, right? You don't build any of that stuff. It handles all of that stuff. You create scripts that are inserted at the appropriate times, and the engine will call on them because you've been a good person and you have implemented their interfaces, whatever they may happen to be. So here we have, int main. Here we have a standard C at the top. Then we have a C# class static void main one, and then we have a Java public static void main below that. Get that stuff out of your mind. We're not dealing with that in this class. You will not have a main function, okay? You don't even get constructors unless you're writing pure C# code, just so you know. When creating Unity scripts, you are given a class declaration that is going to match the name for the script and inherits from mono behavior. So let's break that down a little bit. What does that mean? In Unity, let's actually have Unity open really quick. If we come over to our project folder, and once again, the UI, all that kind of stuff, it's covered in the videos. I'm not going to waste time on that. We're going to talk specifically about C# right now. In this project panel, and by the way, my layout will look completely different from yours, but if you follow the videos, I show you how to edit it and make it whatever you want to. Let's just choose default so that if you're following along, we'll have something similar. In this project panel down here, I'm going to right click. I'm going to go to create, and right here you see C# script. I'm going to press C# script, and what you'll notice is I get a new icon with a nice sharp icon for the music fans out there. But what we can do is, while it's highlighted, we have the ability to change its name. This is important to do now. Let's just call this, what do we have before? We had entity or mortal. We'll just call this mortal, right? you get that one chance to give it a name. You can change it, but what I want you to see is if I right click and go to create and create another C# script, and you know what, I click somewhere else, okay? I'm going to double click on these to open up Visual Studio because I already have Visual Studio associated. If you didn't have Visual Studio installed on your computer beforehand, and this is your first time, it will automatically have been installed and your association should be fine. If you had other versions of Visual Studio, you need to go to Edit, and then what we're going to do is go under Project Settings, and under the not Project Settings, Preferences, Edit, Preferences. And under Preferences, we're going to come over here, and then here you have External Tools. External Script Editor, you'll notice I have selected as Visual Studio 2019. You may have 2017, 2015, other things as well, Notepad++, whatever it is you want to use. I highly recommend you use 2019. There's a reason it's built in with the installer at this point. It works very well with Unity. Anyway, when I named that Mortal before clicking off of it, you'll notice that the class name is automatically Mortal as well. It changed the class name to reflect that. However, here I made one called New Behavior Script. If I double click that, you'll notice it's also called New Behavior Script. No one is ever going to want that to be the name of their class, all right? Because if you create new ones, you're causing naming problems already. So watch what happens. If I change this, let's say this one is going to be Entity, right? Like we talked about. And I'm going to hit Control S to save it, Control S, or go to File and then Save up here. Make sure you always do that so that when you go back to Unity, the save is registered and that its script in the project is updated as well. If we come back here, we give this a second, we're actually going to run into a bit of a problem. Sometimes you'll get an error, sometimes you'll get a warning, but what you'll notice here is that I have the name New Behavior, but the class is called Entity. That's not going to work. In fact, if you try to run this or put this on an object, you should get an error, okay? The name of the script has to match the name of the class exactly. So now I have to hit F2 or right-click rename and type in Entity. Why am I taking so long to do this? Because this is like the #1 error people have and they mess it up when they're first learning Unity. This name has to match the name of the script perfectly. This will not cut it. Capital matters, okay? Capitalization matters. So make sure it is exactly the correct name, and that will save you a lot of headaches. Okay, so that's what that meant. You create a script, the name of this script file and the name of the class need to match perfectly, all right? And it inherits from monobehavior. The reason why I spent time talking to you about object-oriented programming is because the scripts that you create, you can't get away from it. Right here, remember that colon I talked about? There it is. And there is the class it is inheriting from. It is inheriting from a class called monobehavior. In the videos, we actually go through and we click on these classes and go step by step and you can see that we're inheriting from component, from object, until we finally get to the base Unity class that is called an object class. To do that, I'm actually holding Control. When I hold Control, you'll notice that these become hyperlinks. Then I can go through. But the great thing here is I can actually explore the entire hierarchy. And like I said, it's in the videos if you want to watch that and learn a little bit more about it. Moving on. And once again, I do not have the chat open in case people are talking.
Professor Lecakes,
Yes.
is this like a library that we are calling?
Correct.
Monobehavior? Okay.
Correct. That is
Just to make sure.
within up here at the top. We haven't quite gotten to this yet, but up here you're having these using statements. If you would like to think of these as includes from C or C++ or other applications, these are different namespaces that have been defined. There is a system namespace with all the system functionality. Under that is another namespace called collections, which hold various kinds of lists or decks or queues or dictionaries, different things like that. And under that actually is another one called generic, which you would think that generic would mean that it could use anything, right? But actually generics use those little funny caret operate less than and greater than ones to refer to a type. You're actually exclusively sticking to a specific type of object. So I would use a list. So I did a list and I would type type mortal, right? We'll say that mortal itself holds a bunch of mortals. In this case, I've created a list. I'll just call that mortals, plural, because it's a list and lists hold more than one thing. That's why I would use plural. And I could do new list, and I could call this mortal, right? So there I've declared and defined a new list of mortal objects. And once again, this type list actually resides under system.collections.generic. If I didn't type using system.collections.generic, I have to do this nonsense, and this really sucks. System.collections.generic.list, and then mortal, right? No one wants to do that. So that's why we use using. And similarly, using Unity Engine is a namespace with a tremendous amount of Unity functionality built into it. And that's if you, let's load up let's not show bookmarks. Turn that off or not. Let's go to Unity Docs, Unity documentation, right? Here's the manual if you just type in Unity documentation. But what I really want to look at is actually the scripting API. And what it's going to do is show you the namespaces that contain all of the Unity code that you're going to be working with. Here we have Unity Engine and Unity Editor. Everything you do for right now until week 7 or 8 is going to be within the Unity Engine API. And there are sub namespaces within that. One's for AI, Android, Apple, iOS, and many other classes that you'll be working with, okay? And then there's also, when we get to week 8 or 9, I forget which one it is, there's Unity Editor class, which are methods, features, and functionality that allow you to extend the editor. That is the thing that we just looked at, this thing, this right here, allows you to make new options, windows, interface items, and so forth. That's what we'll be working on in that particular lecture. But become friends and make this a favorite or a bookmark if you can, because whenever you don't know something, you literally, like next week, we're going to be talking about vectors and meshes and how to create 3D objects. Well, just type in vector or vector3 or whatever you're looking for, and it will tell you everything you need to know. And really importantly is that up here is version number 2019.4. Because features and functionality changes through time, choose whatever version that you're working with as well and make sure it's the correct one. And you'll see everything that you have access to. But this is also why I like Visual Studio and other IDEs that provide things like IntelliSense, because I don't need to look at it. All I have to do is I can just type this dot and I can get a list of all of the features that I have. You know, just do this and sit there for a few minutes and just read them. Most of them make sense. Get component. Okay, I'm getting something called a component. A component is a piece of something, so I'm getting some piece of something. Okay. Get children. Okay, child objects. There's probably something under me, right? Maybe. Invoke, make something happen. Name, the name of the thing, the tag. Familiarize yourself. Take 5 minutes and just go through the list and get used to the names and how things are done. It will save you so much time in the future. Let's see. So that being said, this script that you create has 2 what are called event functions, all right? And that's the terminology Unity uses. A long time ago, people called them magic methods because they don't quite use the nice little object-oriented stuff we were talking about a little bit ago, like things like override or virtual functions and stuff like that. We'll talk more about that later. But what it does is these are methods, functions that you get to fill in. These are the most common ones that you'll almost always be using. You get a start method that happens at some point early on. We'll talk about when later. But what you need to know is this is as close as you get to a constructor. If you're not familiar with what a constructor is when you did new mortal, right? New mortal is calling the constructor. And in that constructor, you get the chance to say what you're going to do to set that object up. In Unity, start, or if you're a Unity pro and you know this stuff already, you might also be familiar with void awake, right? And void awake is in many ways awake actually happens even earlier than start. It gives you like the earliest possible point for you to do something to set your object up. And what you can do is, if we go to Unity really fast, I'm going to type in, let's see, we want Unity order of execution. Let's see, there's a really handy diagram that yes, this is it. It's too big to put on a slide. It has to be on a website. But this shows you when Unity, the combat manager I showed you, right? we had a list of tasks, right? And anyone could give that combat manager those tasks, and it would iterate through all those tasks at the appropriate time and execute every single thing that occurs, right? This is the same thing. Unity Engine is a manager. You give it tasks, or that is, you subscribe to it. You implement that awake, start, update, and Unity calls your method at the appropriate time when it gets to that point in time. So initialization, awake, enable, editor, reset, don't worry about that so much. But physics updates, or updates in general, if we scroll down, we want on update. So we have actually several different updates. We have a general update right here, and then we have a couple other things. Don't worry, this will make much more sense. I just want to show you that at specific times, Unity is going to invoke your code at the appropriate time. And that's your chance to execute your functionality, okay? And then you have something called late update, which is after all the other updates have occurred. Why do you need that? Well, maybe you need everything to be resolved before you can make a decision. So a late update would be the right time. Do not feel concern about learning a system and then having to throw it away. You're like, why am I using this Unity thing? I'll never use it again. The system that Unity employs, where you are registering or subscribing or inputting in or inserting functionality at appropriate stages, is used in many software applications all over the place. And if you plan on implementing or extending or adding code in the future, whether it's Lockheed Martin or somewhere else, they probably have some monolithic engine, and you will be inserting things by implementing some interface or abstract class or something that someone else has already designed. How to do this and the why are everywhere. The specific names for things will change, obviously, but it is important to understand and become comfortable with in order to be successful later on. Same thing with Android programming, okay? Same thing with all engines for the most part these days. You need to get familiar with this kind of stuff. And don't be like me. I'm the guy who looked at this stuff and said, well, I don't want that. I want to learn it hardcore. I want to know how to program OpenGL and DirectX from the start. I want to do the Windows programming myself. Don't. You will lose years going down that deep hole. You'll get nothing done. You'll understand everything really well, but that only matters now that I teach, right? It doesn't matter if I need to create something. So don't do that. Only learn the lower things when you need them and it's necessary, okay? I'm going to give you peeks and insight at times into the lower levels of things and how they work and why they work when we go over the theory. But be confident that you're learning something useful and that you'll be able to use when you use the Unity engine, okay? That being said, let's continue on. So these are some example event functions on the sides. It's not all of them, but it's some of them, and it's probably the most popular ones that we'll be working with in this class. One thing that's important to understand is when you create a script, you're creating something that's meant to work inside of the Unity engine. You're inheriting from mono behavior. You don't have to do that. We could have created a new script and made it pure C#. That is, if I right click, go to create a new C# script, and let's call this stats, right? This is the stats one that I made before. So let's see, I'm getting some errors here, mortal, because I had written some code. Here are the errors popping up. It doesn't matter. Like I said, whenever you're programming in this stuff, if you double click on the error, it takes you right there. It's saying, hey, you've got this thing, private void awake, but that's not the actual error. The error is above it, right? Because this thing doesn't know what it's doing because I didn't properly write this. So if we delete that, this error will disappear. I hit Control S, that will disappear. Come back here, that error disappears. Then we move on to the next one. Double click that, identifier expected. Well, I didn't finish this. All right, delete that, don't need that. Control save, go back, come back here, check it out. All the errors are gone. That was simple and easy, but it's important for you to see how easy it is to fix errors in Unity. The errors are spot on almost always. And literally, I spend every day correcting 7-year-olds watching my YouTube videos trying to make Five Nights at Freddy's in Unity and answering really dumb questions. So yours will never be as low and as bad as these questions. So never feel like you can't ask me a question. I have answered them all, okay? So always ask things. But anyway, back to this stats. So here we have our stats class, and what we'll notice is that it automatically, Unity will always inherit from mono behavior. Well, delete it. I don't want to inherit from mono behavior. The reason why we inherit from mono behavior, as you'll learn in some of the videos, is that if I want to attach this, you remember that thing called a component? If I want to attach it to an object, if I want it to be a component, it needs to be a model behavior. This can't just exist inside of my Unity scene. It has to exist within something else inside the Unity scene to actually get created or to exist. So that's something to understand. But you can create pure C# classes, and many times you will want to for like an inventory system, or maybe different properties, or maybe an XML reader or writer, or things that have nothing to do or any business in Unity itself, dealing with the game engine stuff. Don't make it part of it, keep it separate, and then you can reuse your code later on inside of something else. So going on, simple C# class. Class declaration at top. We've seen this a few times now. Public, everyone can see it. Class inventory. Make sure it says public. If it doesn't say public, you won't be able to access it. And most of the time you want your classes to be accessed. We can talk about reasons you wouldn't later. Then we have our attributes, right? Or members as they're called, or fields or variables. Once again, terminology kind of sucks with this stuff, but I will call them variables because that's what I think everyone knows across all languages. You have different accessor methods: public, protected, private, a bool, an int, a list. All of our favorite types from C and Java are here for us to work with. Then we have our constructor. Remember, the constructor is the same name as the class, right? Inventory, inventory. The only difference is it does not have a return type. It should not have void or anything. And it can take parameters if you want to. We don't have one. And what it does in this case is when it gets created, it generates, it makes the list. Okay, we had a list variable up here. You'll notice I set it to null. Null is a very important keyword you should all become very familiar with. When you're dealing with types that are not data, you can work with nulls. And even that's not quite correct with C#8. But for everything you deal with, when you're dealing with objects, by default, when you declare them, they will be of type null until you instantiate them, until you use new to create them. Here's an example of creating a method or a function, right? Accessor method, return type is a bool, and then here it's called receive item, and then we would pass in some item. What this method would probably be could have actually been part of an interface, right? Maybe inventory has an interface called I. We usually put an I in front of things when we talk about interfaces. I inventory, meaning if you want to work with the inventory, you need to implement this interface. And receive item could be something that we require anything that we create to have in order to work with the inventory system, right? So receive item with an inventory system would receive it, would do its little code bit, determine whether or not it's allowed to, if its inventory size is right, if the weight's not too high, all that kind of cool stuff. And it would return to you true or false whether or not that item was added to the inventory. And if it returned false, you could, in your game code, your manager, drop it on the ground, or you could make it disappear and store it in the actual inventory. And these are different ideas. And hopefully you're seeing how things can be used. Here's an example where we actually have an inheritance being used. This is not a real class. This is just stuff I'm making up. So don't try to find this. Here we have a public class called oscillate. Let me bring back my pen here. So we have the name is oscillate. That would be the same name as the script. So we would have a script called oscillate, word for word, letter for letter. And it's going to inherit from something called animatable. Who cares what animatable is? From its name, it means I can probably cause this thing to change over time. That's what an animatable would probably be. Here we've added additional functionality. We have something called cycle, right? And cycle, the reason why this class is called oscillate in my head is because I want to be able to oscillate, right, back and forth. Now I could do once and stop, or I could cycle back and forth, right? And then here we have something called a clip, an animation clip set to null. Doesn't have anything there right now, but I know I'm probably going to need it. I'm going to need to set it to be something. So I have it as a member variable. And then here I have the constructor. How do I know it? No return type. See, no void, no nothing. It's also got the same name. It takes this thing in. What's important here is that how do you call the constructor on a base class? This is how you do it in C#. You literally write base with parentheses, okay? And then you would pass it any parameters that it would require. So you would need to use a documentation to find out what it would require if you want to, or you can use IntelliSense to autocomplete. But using :base is how you would call functionality in a parent class, or call the constructor of that class. Here we have this dot animation clip. Once again, I use this to make sure that I am working with the animation clip stored in the instance. Why? Because I also named it animation clip here. Okay, and that's to distinguish between this temporary variable, which has a local scope of just this constructor. As soon as the constructor dies, that parameter is gone, versus this animation clip, which will persist so long as the instance persists in memory. Okay, so just keep that in your head. I use this a lot to refer to variables so I don't have to come up with shortened versions. That's another popular thing people do. They'll call this anim clip instead. Like, oh, that's shorter. Now I know that this is the parameter and this is the actual one. But believe me, in every project I've ever worked on, you run out of names real quick. So it's just easier not to have to do that. Then we have public override void, and that's play. So this is the idea that this is the method that would play it. Override means we're overriding functionality that was already there. This functionality came from animatable or from some child class, or some, other parent class. Maybe animatable has another parent class that's just animate or something else for that matter that has the play thing. Either way, we're overriding that and we are providing our own functionality, because normally an animate object might not oscillate, go back and forth. But this one we've created not only animates, but we want it to always go back and forth and to oscillate, to ping pong, right? To reverse the direction and start over here. So here we have some kind of a check that I created to make sure that it will always do that kind of functionality. So let's get into C#. We don't have much time left, so let's wrap this up. There are two types of types in C#, value and reference, okay? And this gets down to a lot of confusion where people are like, okay, did I pass a parameter in and is it a copy? And do I lose that? Any changes to it? Or is it the actual object? Values contain data, directly contain data. They have their own copy of it, an integer, a float, a bool. All those base types that you're familiar with are passed by value or value objects. References are objects. Behind the scenes, you can think of it as a pointer to that object, right? It's a pointer to, it's an alias to that object, okay? It's not the actual object, it's how to get to that object, right? These are, I keep using the term object because that's what they are. They're called objects. Two objects can reference the same data. That's important when you have things like large arrays or lists of data, right? You could have data 1 and data 2, and each of them has a list inside, right? This has a list, this has a list, but they're both pointing to the same memory location, the same list object. So when this guy over here makes changes to it, this one also gets those changes done to it, all right? And that's where you get into things like deep copying and other stuff that hopefully you've heard of before. When you're using arrays or other things, you make sure you do a full copy as opposed to a shallow copy, which is usually just a pointer. More types. So value types, simple types. I've already said these: int, byte, char, float, bool, so forth, so on. Enumerations are value types. Instructs as well. And what you'll notice in Unity is that a lot of the base classes like vector, quaternion, and several other ones are usually structs as opposed to classes for efficiency reasons. Then we have reference types. These are the ones that are more like a pointer, right? That contain data, and you have to be careful. Class types are objects, anything that is a base class of object. It could be a string or any user-defined class you create. It could be any interfaces. It could be any array types, so the lists and all the other things you use. And then finally, something called a delegate, which we'll briefly cover, but we're not going to go into deep. But you will want to understand what delegates and events are later on. But really, a delegate is nothing more than a function pointer, if you're familiar with that in C or C++. And hopefully you've done that a few times. It's just a pointer to a function so that you can call a function without having direct access to its name. You can store it away in a variable and throw that around and then call it later. So here you go. Here are all our common variable names. So commit this to memory, obviously. No. But, you know, things you probably want to remember: a byte, an int, a float. Definitely everything is floats for the most part. Try not to use doubles, because doubles are 64 bits as opposed to 32, and they usually require more hardware support to work properly. So if you can, use a float. Char, bool, that's pretty much what you need to handle for the most part. Do note that I have two different names for these things. This is the true name over here. system.double, char, bool. Notice that they're all capital, right? As opposed to these names, which you're probably more familiar with from other languages, okay? These are the true names. However, they get aliased or, type defed over to these names for convenience. So use these ones, but do understand if you go rooting around in the system documentation in the folder, these are the names you're actually going to be finding that define everything about that object. Array declaration, really easy. Brackets, just like C, C++, Java, right? We can initialize the array if we want to over here. We can declare it with new and specify its size right here. And then you could iterate over it and then fill in each one with an actual value. Same thing here. Here we've created that new array, but then we also initialize it. And then if you need to create a two-dimensional array, you can do so here by using a comma. And then you would specify the size of the array in the new statement. And what's important to understand then is you would want to then iterate over the array and fill it with values after you're done. Many times you'll create a method or a function that will auto do that for you and initialize things depending upon what you're doing. Next up, referencing arrays. An array of variables of type reference are null. Null is that keyword I keep talking about. You're going to see this a lot. Type is null, or null type detected, or could not do something because it's null. Null means it's not there. It's nothing. Nothing's there yet. It's a placeholder to indicate absence of something. Understand that things are null by default. When you create that array, as you see here, it's got a block for each of these objects, but they are null, right? There's nothing in them. It has not created that object yet. You need to iterate through a for loop or something and fill that with actual real information, okay? var, once again, laziness, as I call it, because I always like to know what my data type's in. I worked in Python for over 6 years, and I love knowing what my data type is because I hate if you've ever done Python before, there's the whole looks like a duck, quacks like a duck, then for it is a duck, and you don't really care about what the data type is. But I do. The keyword var replaces the variable type. It's to implicitly define something. What happens is you write var, what is this? Usually you write this when you're lazy and you don't want to look up the documentation or someone hasn't documented something, right? You don't know what this is going to return, but you know you need it. So you're just going to say var, whatever, and you get this object. var does have really important aspects, but you are not going to touch them early in this class. It's usually used more lazily by people at the beginning. The true benefit has to do with what are called anonymous types later on, where you don't know what the type of the object is. Literally, the word anonymous should explain that to you. And that's where var becomes powerful and really important to use. If you know the type, just write the darn type. That's my stance on var. C# functions and methods. A function contains behavior. We know what functions are, hopefully. You have your accessor, public, protected, private. There are optional modifiers that we'll talk about soon. You have your return type. Remember, a constructor is not a method because it doesn't have a return type. And then you have the name of it, which should always be a capital. Always be a capital. Please capitalize. And then you have your parameters, whatever they might actually be. And then you have your body of the method. One of the biggest things people mess up is they forget to put enclosing curly braces. Don't let that be you. And yeah, I did all that. Let's see. You can overload methods, just like C or C++ and Java, where you can use the same method name but provide different parameter inputs. You cannot overload. Overload does not include return types. That is not part of the overloaded method. So you cannot return multiple things but have the same parameter list because the compiler can't figure out which one it should actually do usually. Methods are accessed using the dot notation. So with object-oriented programming, you're going to do things like this because it's the instance dot, and then it will have all of your variables, methods, and so forth that you can access at that time. Once again, if you need to, this is here for you. But return type, name, and then the object, right? Here we made a method check collision type. It takes in a collider. We use the dot to gain access to either attributes of the class or things that it contains, right? So it might contain, the collider has a reference to the game object. You'll learn about these concepts later. That has a method or a function called compare tags. So you'll be using the dot operator a lot to move around functionality and different objects inside of Unity. And that's much of your battle with Unity will be making sure you move through objects and you know how to get access to the things you want to access. Parameters can also have keywords. So not only the type, you can specify it as being in, reference, or out. And you'll see this in a few different examples. But the idea is to once again, to enforce things. So in means pass by reference. It's only read, it can't be written to. Reference means it is a reference to that object. You can edit it and mess with it. And when it comes out, it'll also be messed with based upon whatever that function did. Out means you're going to be passing something out of it, a reference out of it, okay? Many times out is used when you need to pass multiple things from the return, okay? Or it's to change how a function works for convenience to make it easier to work with. For instance, raycasting, which is to determine collisions, uses physics.raycast inside of Unity. Fly. This method will use out. That is, you specify a point and a direction that it's supposed to be casting out to, and it will then determine anything that it hits, and it will fill this ray hit object with all of the different hits. But to make this function easy to work with, instead of returning the hit, it actually returns a bool, yes or no, because then we can wrap this in a if clause, right? So if it hits something is what this actually means. And then if it does, you can then go into the hit object and determine exactly what it was. Whether or not it hit something is more important than what exactly it hit or didn't hit in that case, because then out, you would have to look at hit and see whether or not it was null. And then you would have to do a null check, and then you would abandon it. This makes it more convenient and easy to work with. So that's where you'll see that. Passing by value and reference, value types are passed by value, obviously, because that's why they're called value. Pass by reference means you're passing the reference instead, so you're sharing it. So be careful there. Classes versus structs. There are some differences between the two. You can look at this chart if you want to know exactly what they are. You'll notice some parts cheaper allocation. However, at other times it's not cheaper. If you have lots of it, it ends up being the classes are each easier. Less features and so forth. A constructor or deconstructor is with classes, but you don't have them with a struct. Once again, remember back to that example I did where we had the generator and we were generating different classes of type mortal, like an ogre or human or whatever it was. Like a struct might use that method of generating things as opposed to the object or class type on the side. So in Unity, you're going to be using a lot of different classes, and we're going to be using them next class, specifically vector 2, vector 3, vector 4, and color. And I call them classes to show you that they're not. They're actually structs. If you look in the Unity documentation, they're under the class folder, but they're actually of type struct. So there are benefits to doing that. You can and will see nested classes. Usually they're hidden and they're meant to encapsulate functionality that doesn't need to be anywhere else. But you also didn't want to include it in the class, so to speak, and mess it up. You wanted to encapsulate it into its own thing. So here I have a class person, and I might have a class hand inside of it that does all the hand stuff that it should. And a person would have two hands in that case. It would declare two instances of hand. Virtual, override, and base. Important for inheritance with C#. Virtual allows a child class to override a method. When you declare a method, like here is the parent class right here, right? It's person. Here I have a function called getInfo, but I could see that getInfo might want to be overridden in the future. So I declare it as virtual. So I foresee you wanting to mess with this. So then when I declare another class called employee, called person, you can use the override keyword to signal to C#, hey, I am taking control over here and I'm overriding getInfo. So get rid of that stuff, okay? Or don't get rid of it. Here, I'm calling base dot whatever the function name was so that it does whatever the parent class did. Parent class is doing important stuff for us, right? It's writing out the name and social security number. We want to keep that functionality, right? But we want to add. So we override, call the base, and then add our own stuff on top of it, okay? Let's see, seconds, minutes. C# interfaces. Interfaces are not classes. We've discussed that. They can only declare methods. They don't implement them. Classes usually have an I in the beginning. So if you look at Unity interfaces over here, I animation, I canvas, I exposed. That's how you know. If you create interfaces yourself, Try to stick to that convention. It makes everything easy for everyone in the future. Here, for instance, we have a class called test class. And I have an I float, I eat, I attack, right? This not being a floating type variable, this being like if I float on the water. But those are all different interfaces to allow for floating, eating, and attacking that this class would implement so it could work with those particular systems. Abstract classes, we kind of already saw this, but once again, here's a shape, and here's me creating a square. The idea being that I have defined area as abstract, but I had, code or variables that I needed, like position. Every shape has a position, so I need that to be in there, right? So it needs to be abstract as opposed to an interface. Here, I inherit from it, I get a position, so I know where to place the square, right? Maybe that's the center point of the square, but I also override and fill in area in this case. So just keep those keywords in your head: virtual, override, stuff like that, abstract. Make sure you know what they mean. Conditional is true and false. If else, all that good stuff. Switch statements are here as well. Then of course there's var. There's the ternary operator as well, the conditional that allows you to return, here's your expression. This will return true, this will return false, so forth and so on. There's one thing. Switches are far more versatile in C#. You can put in a lot more types than you could in C or C++. Two different kind of loops in C#. We have a for loop that you're familiar with here, where we have the 3 different parts to it. And then that works however you want to. You get to increment it and change that increment however you want to. For each is restrictive. It's meant to go over an entire list. If you need to change that increment, like jump around based upon what happens in it, and this happens with a lot of things, or like do every 10 or something, you don't want to use a for each loop. This is for every single one. This is for if you need to jump around and do interesting things, okay? Try and catch loops. Try and catch, I'm throwing these concepts out here. Try and catch you'll use from time to time when you're accessing resources or devices and whatnot. But for the most part, you won't need to do that. And we're out of time. So what I would like you to do is, if you can, go over the remainder of these slides in your own time. They're already up on week 1. There's not much more. The part on delegates, look it over. Don't worry about it too much. It's easy enough. But we're not going to use these for a while. But just get familiar with the terms. Make sure you know them so that when you see them someplace or in a tutorial or something that you're looking at, you know that they exist. You're not just going to, get scared and run off. What I will do, though, is next class, I will go over coroutines. That's important enough to show you an example of so you understand it. And yeah, that's pretty much it for our first class. Does anyone have any questions or anything they'd like to say before we end it for this week? This class was a lot of talking, and that's because it's the first class. I got to get everyone up to speed and on the same page. Things are hopefully going to be a lot more active, and we're going to have a lot more back and forth once we have something we're actually programming with, and that is week 1. Please go on Canvas and look at what's due if you have not already done that. And of course, it's going to ask me to do all this stupid. Yes, Duo. Yes. Thank you. Can I please access my course so I can talk to my students? Sorry, everyone. I know everyone wants to go, or you have other things to do. Check out week 1. It should be unlocked. If it's not, let me know. The lectures are up there. Video lectures on things we didn't go over. Please, if you have, go over these. These are going to talk to you about the basics of Unity. I spent this time going over the theoretical side of things, the background on the language and the concepts. You need to spend the time going over these videos to familiarize yourself with Unity so you know how to use it. I can't answer questions on this, but I'm trying to not have to redo everything in these things. This link will be updated to be the recording as soon as I have it up there. The course information slides are up there. The quiz. You don't have to, I don't know when the due date is on the quiz. I'll probably push it till like next class. So go over all the material. You have the whole week, then take the quiz when you feel confident that you can. The quiz you notice how it's called Unity Basics? It's going to cover things in those videos. So go over those videos as your homework, okay? And then there is a very, very simple basic homework assignment to submit this week. You're just creating a new Unity project. adhere to the conventions required. You're creating a plane in the scene at 000. You're going to rename it. You're going to create spheres. You're going to understand what a parent-child hierarchy is. You're going to change the size and scales of different objects. You are going to create a material, and you are going to add a component. And all this is covered in those videos that I created. By the way, though, those are videos I created specifically for this course. I know a lot of faculty are getting crap because they link to other people's YouTube stuff. All that was made for you. It's all new. It's all original. It's just for you to work with. Okay, I'm not going to reuse anyone else's stuff. Run your scene, and then you're going to zip the entire project up and send it to me. Let's try to do it through Canvas, and if it doesn't work, I will give you a Dropbox or a Google Drive to do that. Any questions? I know I'm over. I'm sorry.
One quick question I had, particularly for HLSL, we'll get to that. Do you have any resource suggestions for further readings, things like that?
I can give you references. I will, maybe at the end of each module, I'll add like some references you can look up yourself. I do have a few you can look up for HLSL, but the truth is, HLSL, the Microsoft documentation online is the best thing, period.
Mm-hmm.
I know you don't want to hear that, but it is. I have like 8 books behind this thing on it, and they're all old. No one is writing new stuff on HLSL. It's all coming from Microsoft. Okay?
Yeah, that's about what I found out as well. All right, thank you.
Anyone else? All right. Thank you all for being courteous and all arriving and being here on the first day. I will see you all next week. Remember to email me or reach out if you have any questions. Bye, everyone.
Have a good
Yes, the recordings I am going to end, and you will get access to it as soon as I upload it, whether that's directly to this or to YouTube in the next 12 hours, I'd say. All right.
Thank you,
Go ahead and
Professor.
end this.
Have a good one.
Goodbye, everyone.